about.
have a very good opinion.
I just ended with this like the end, so I feel like someone should be like.
I do too. My last slide just says thank you. I mean, it says thank you.
I feel like give say.
We're just gonna tell him he's gonna do it.
I have to, yeah. That's
Okay,
fine.
I think it's better.
It's fine.
It's better. They'll just like break the smell.
I always forget that if I wear this shirt and this thing, they're both like,
That everything has like,
yeah.
Definitely, yeah. It's like, okay, now we're going to this.
and now,
Yeah, no, I think we need to do it.
Market forces are
the gift's gonna stay in it.
between people.
So I'll just say all the persons. Yeah, because we're going to be getting up and walking. Yeah.
So you just can't stand over here then?
Well, wait, are we done? Yeah. I just say probably. Yeah.
Oh, you can just say it. Yeah, that makes sense.
We're all.
So actually, we don't need to speak into these. That's
No,
good.
like
Yeah,
before,
right.
I thought most of it's just.
Yeah, I think I need to stand.
Oh, and Marie can sit here.
Yeah, I'm gonna stay here.
Yeah.
When you did your right, but you're gonna sit there.
Yeah, but we'll sit there and all the rest of it. And then we'll
I think the sitting had to do with some things were just panels without slides. There was like a
Well, I definitely was a panel.
yeah.
Gifford, how do you say my last name?
Is that like the Enoch?
Yeah. Well, I mean, it originates from German. It used to be Trucken.
Don't practice that.
You're gonna totally sure that's my name. So we have the same
Don't
you.
don't do drunken.
Ted Sure.
Just like sure?
Yeah.
No.
No. It's true. There's a whole
Don't
Dutch,
give me the-
there's a whole Dutch pronunciation, but I won't tell you that.
Okay.
The Americans say Ted
Not
Sure.
in the negative half minute we have because
Yeah,
it's
exactly.
already 8:31.
Right. Okay, shall we go sit down?
Yes.
And
We
now
sit
we
down
can-
up here, or
Yeah, we'll sit
yeah.
down here.
Yeah, we're 2 minutes in. We're already late.
We're gonna start 5 minutes late.
Oh, sorry.
No. Good morning. Wow, that is amazing. Good morning and welcome to the second day of the Arctic Futures 2050 conference. I first want to take a quick moment to thank the panelists and moderators from yesterday. as well as the hardworking search organizing committee members who've worked tirelessly to put this incredible conference together. So many things under this great angular roof tent. So let's just give them a quick round of applause. And obviously, as you could tell by the timbre of my voice, I'm super excited to be kicking off the second day with this amazing panel. Their bios, like yesterday's bios, are all in the conference packet. So they sound as good as these people look. It's amazing. What you need to know now are these 5 fine folks are about to take you on a journey. I'm sorry, Siri? How to fix the Arctic? So like I was saying, these 5 fine folks are about to take you on a journey, one that starts and finishes on a coast, with each one talking about the consequences of a rapidly changing Arctic through their personal lens. We begin with Maya Lukin with the National Park Service, who describes some of what it is like to live, thrive, and survive in coastal Kotzebue, Alaska. The next 3 speakers, Matt Druckenmiller and Twyla Moon with the National Snow and Ice and Data Center, Ted Shore with Northern Arizona University, they'll share their perspective on 3 iconic components of the physical Arctic: sea ice, permafrost, and land ice. They're representing the science action teams within SEARCH that work to synthesize and communicate science. We'll then zoom out from the Arctic and hear from David Bihar with San Francisco Public Utilities Commission about how challenges facing the Arctic are already affecting communities outside of the Arctic. So without further ado, Maya, would you mind kicking us off?
Thanks, Gifford. Like Melanie, I too got sick when I arrived in DC, and I promise it's not an allergy to politicians. See if modern technology works here. Uvlalotak, uvangakatak kikikdagrug mirunga lisisoli rogarunga, uvangakokhluk, Western Arctic National Parklands, Savaktunga. My name is Maya Lukin. I am the superintendent at Western Arctic National Parklands, 3 parks above the Arctic Circle, managed by the National Park Service. I'm from the shores of Sisolik on Cape Krusenstern National Monument, pre-Anilka, around 1977. The enabling legislation of the 3 parks came under the Alaska National Interest Lands Conservation Act, established in 1980, and 2 of the 3 parks legislation specifically calls for the protection of subsistence resources and cultural resources. Part of protecting those resources includes monitoring permafrost, climate change and weather, changes in lakes and lagoons, coastal erosion, and massive changes in the migration of caribou, salmon, whitefish, and other subsistence resources. Today, as in the past, many Alaskans live off the land relying on whitefish, wildlife, and other wild renewable resources. Whitefish is on my mind, sorry, I'm gonna keep saying that because that's literally the time that we're doing it right now. And I keep thinking about it. Indigenous people have used these subsistence resources for food, shelter, clothing, handicrafts, transportation, trade, and other goods for thousands of years. Subsistence and all it entails is critical to sustaining both the physical and spiritual culture of Alaska Native peoples, and it's a really important tradition to non-natives as well. Subsistence users have a unique connection to the land, fostered by tradition and lifelong experience, traditional ecological knowledge, indigenous knowledge, traditional knowledge. It's the system of knowledge gained by experience, observation, and analysis of natural events that's shared among family members. In subsistence, that knowledge is used to find, harvest, process, store, and sustain natural resources necessary for survival of the people who live there. Subsistence is synonymous with our culture, identifying identity and self-determination, and we face challenges daily, from changing weather patterns, diminishing sea ice, coastal erosion, and the uncertainty of migration routes. All northern Alaskans feel the effects today, and this is where Arctic research comes in. The research goals directly affect our subsistence activities, and it's important for scientists to work with hunters and traditional knowledge holders to ensure that projects are completed that benefit both the people directly involved and directly affected, as well as the research agencies themselves. The Arctic Network is a part of the Inventory and Monitoring Network of the National Park Service, and it publishes a weather and climate summary for Arctic parks quarterly. Some highlights last quarter included of the 10 warmest summers on record in Western Arctic National Parklands, 8 have taken place in the last 15 years. Weather anomalies were 8 to 16 degrees warmer than normal. In March, Kotzebue hit 41 degrees above zero, which for many of you isn't that warm. The highest temperature ever recorded in March in Kotzebue, Alaska. Other records were also broken in March, including the lowest sea ice ever recorded over the Bering Sea and the lowest sea ice in Kotzebue Sound. Unfortunately, our weather is changing so rapidly that people are dying. Subsistence food security, and Inupiaq culture is being lost, and thousands of years of data is being washed away with each season's storms. Thick ice is essential for safe travel between our communities. In an area of the world with no connecting roads, winter travel by sled dogs and snow machine happens every single day. You take the metro, we take a snow machine. Our area is about 38,000 square miles, mostly above the Arctic Circle. Within that area are 3 parks, 12 cities, and villages connected by river, ocean, and overland traditional routes used by thousands of years. Both my uncles were lost when they traveled at a normal time in the spring to our camp, fell through thin ice with their snow machines and gear, and we never recovered their bodies. Last year, my cousin went hunting in places he had hunted safely for 30 years, and he never returned. And his snow machine was seen a week later submerged and frozen in place. And this April, a family member of mine went through the ice with her husband and 11-year-old niece. All 3 perished in a place where ice had always been safe to travel. Administratively, as a superintendent, you have to take into consideration things like that. Overland winter travel is important to the Monument Park and Preserve, and the cost to fly in remote Alaska is tremendous. But the uncertainty of the thickness of ice means a higher cost to those of us tasked with managing the land and ensuring the safety of our employees. To ensure that safety, we now have to pay for vendor flights, which we once could have easily safely traveled by snow machine to all 3 parks. And the cost difference to the public is approximately $3,200 per trip, per person. I said before that 13,000 years we've been living in the Arctic for 13,000 years. And an archaeological site, it's scientifically proven. And we've always said 10,000 years or time immemorial, but an archaeological site in Noatak National Preserve was found last summer and dated to approximately 13,000 years ago. So I wanted to put 13,000 years in context in case you can't fathom that, because I really can't fathom that. So 500 years ago, the Great Wall of China was built. 1,000 years ago, Easter Island statues were being built. About 2,000 years ago, the Colosseum in Rome was built. 4,500 years ago, the pyramids of Giza were being built. 5,000 years ago, Stonehenge was built. 11,000 years ago, the Stone Age ended. And about 13,000 years ago was when Beringia land bridge began to disappear. And for 13,000 years, Inuit people were caribou hunting and seal hunting in Northwest Alaska. That's how far my family goes back. Traditional hunting has been taking place in Northwest Alaska for that entire time, and many of the same techniques are used today, orally passed down from one generation to another, and we calculated approximately 650 generations. The tools may evolve with time and technology, but the traditions all stay the same. And in one single generation, we'll lose that information because of the uncertainty of sea ice and the rapid change we have experienced in just my lifetime alone. An easy way to understand what it means to lose 13,000 years of tradition is to look at your fingernail. The length of your new fingernail is about a quarter inch. It's equivalent to 20 years on Earth. Look at your hand and imagine 1,000 years of history. And if you spread your arms wide, the length from fingertip to fingertip represents the amount of time that the ice conditions were safe. Pack ice was abundant, and cultural traditions revolving around that ice were practiced safely. And in just a fingernail's amount of time, all that has changed. In just one generation, the changes experienced by local hunters on the sea ice have threatened the very culture of those passed down traditions of the Inupiaq people. When the ice isn't thick enough for bearded seals to rest, it forces our hunters to travel much further through rough seas to catch our yearly bearded seal. And it's important not only for cultural value, but for the iron-rich meat that Indigenous people get nutrients from. And our choice is eat seal meat or take vitamins. When we don't have the ice cover the traditional knowledge holders are used to, unnecessary risks sometimes can be taken, and unsafe practices are sometimes used just to ensure that we get seals and we get to eat. Unfortunately, that also means that even though my grandparents, my parents, myself, and my children were taught safe hunting techniques on safe ice packs, proper harvesting, and traditional processing, my grandchildren will never, ever experience that. And the cultural resource loss. When we think about the loss of archaeological resources, information that ties our people to the past, the rate of loss is astounding. And keep in mind that my oral history is an oral history. My history is an oral history. It's undocumented until non-natives arrived. So my only tie to those ancestors lies in the archaeological projects that take place. Nearly 5,000 years of prehistory are represented in the 114 well-preserved beach ridges located adjacent to Krusenstern Lagoon on Cape Krusenstern National Monument. Because the ridges accumulated over time, the earliest ridges lie inland, with the most recently formed ridges and bluffs near the shore. This unusual series of beach ridges presents in sequence detailed evidence of an estimated 9,000 years of prehistoric human use of this specific coastline. Some archaeological sites here are older than well-known remains of ancient Egyptian civilizations, and imagine losing those in one storm. Several feet of Indigenous history is literally being washed away with every single year's storm. In an effort to mitigate that, research takes place on the most at-risk areas each summer, but we can't keep up with the uncommon weather patterns or permafrost anomalies that we've seen in the recent years. So as a federal land manager and as an Indigenous person, it's my responsibility to my tribe and my future generations and the future generations of the public who wish to experience this public land, subsist off of the Indigenous and traditional lands of my own ancestors, and to be proactive about decision-making and mitigating efforts in our parks in areas such as food security, natural resource management, cultural resource management, climate change, policy change, and safeguarding our rich culture and relationship to the land. The local implications of reduced sea ice and melting permafrost are felt every single day above the Arctic Circle. Our climate crisis is right now. We work with traditional knowledge holders, scientists, researchers, other agencies and and experts towards understanding what our changing weather and our changing environment mean both culturally as well as administratively, and work towards making informed decisions and unique solutions to mitigate those changes for the future. Thank you.
Thank you, Maya. That was very powerful. And up next, we'll have Matt to talk a little more about sea ice.
Thank you, Maya, for that powerful and personal account. I'm grateful for being in this room to be able to listen to that voice. So these next few presentations will address in more detail what changing sea ice, permafrost, and land ice mean for the Arctic and for the entire globe. It is nearly impossible to discuss or imagine the Arctic in 2050 without fairly quickly considering the state and the fate of Arctic sea ice. And when we do, we start at a particular scale, a scale that is likely linked to our personal experience. That may be at the scale of daily life, where one can see the snow machine tracks across the ice, as in some of the photos that Maya just shared. Or it might be at the scale of the entire Earth. If, for example, you are a global climate modeler, like Marika Holland, who we heard from yesterday. We each come with an appreciation for the importance of sea ice, but there are real barriers when we come together with different scales of reference, different scales of experience, knowledge, and priorities, especially when the collective goal is to prepare and adapt for uncertain Arctic futures. Throughout my brief presentation, I will attempt to offer a few thoughts as to how we may look to highlight and frame these divides in the context of rapid sea ice loss. So sea ice is our frozen ocean that thickens throughout the Arctic winter and spring and eventually melts and thins throughout summer. Sea ice coverage expands and contracts throughout the year, and across large portions of the central Arctic, sea ice persists throughout the summer melt period into the next winter. This perennial ice is the thickest of the Arctic ice, and as a result is the more resilient ice that serves as a sort of buffer against variability and rapid change. By and large, Arctic coastal communities, like the ones we just heard about, live almost exclusively within the seasonal ice zone, where they experience sea ice for part of the year and an ice-free ocean for the rest. In Alaska alone, over 80 coastal communities live within this seasonal ice zone across the Beaufort, Chukchi, and Bering Seas, each with their own story to tell about how recent changes in ice conditions have impacted their community. As sea ice retreats from the seasonal ice zone each summer, there's an amazing switch in energy transfer at the surface. And a snow and ice-covered ocean can reflect well over 90% of incoming solar radiation. And in contrast, when sea ice is replaced by darker ocean water, the surface shifts to absorbing up to 94% of incoming energy. When the heat enters the ocean, it is then available for melting or inhibiting the growth of ice later in the year, changing the physical and biological characteristics of the marine environment, and altering the Arctic atmosphere well above the ocean. This makes Arctic sea ice one of the most efficient dials on climate that we have on Earth. Climate studies, like the ones that Marika Holland described yesterday, have shown that the loss of Arctic sea ice accounts for over 17% of observed global warming and over 50% of warming in the Arctic. This is even more significant when we consider that the Arctic is warming at least twice as fast as the rest of the Earth. Yesterday, Marika explained how modeling can experiment. They can remove the Rocky Mountains, for example, to see the response on climate. In a similar way, climate studies can remove sea ice, and more specifically, remove changing sea ice, to investigate how well models can explain the warming that we are experiencing. It is critical, however, that models account for changing sea ice, especially considering how dramatic and rapid the changes have been. Since satellite records began 40 years ago, Arctic sea ice has lost over 40% of its summer area and over 70% of summer sea ice volume, primarily through the loss of that perennial multi-year ice. This loss in Arctic ice is disrupting and restructuring ecosystems. For example, sea ice serves as a platform for bottom-feeding walrus. And as sea ice shrinks and recedes into deeper waters, this platform is functionally disappearing. And as sea ice loss shifts ecosystems, it is also changing coastal communities' access to food sources, or at least raising alarms and key questions for how that access may change. For example, as is the case for bowhead whales and other migratory species, there are many unanswered questions regarding how existing migrations may respond in the coming decades to Arctic sea ice change. Additionally, as the Arctic warms at 2 to 3 times the rate of areas farther south, this differential warming contributes to increasing extreme weather faced at lower latitudes, events which cause billions of dollars in damage and thousands of disrupted lives each year. The smaller the temperature difference between the Arctic and the lower latitudes, the weaker the jet stream. And a weaker jet stream tends to buckle more readily, resulting in a variety of extreme weather events ranging from droughts, heat waves, fire seasons, stormy winters, and flooding. So what does this mean? Again, it reveals that Arctic sea ice is one of the most efficient dials on climate and on the services that we derive from our climate. Yet actions today are turning that dial in only one direction. A study from a few years ago observed a linear relationship between this monthly mean September sea ice area and cumulative global CO2 emissions. These findings allow us to quantify each of our contributions to anthropogenic CO2 emissions as having an impact. In everyday terms, this means that a seat on a round-trip flight from Seattle to Washington, D.C. is responsible for the loss of 15 square feet of summer sea ice, effectively the size of a dining room table. I offer this not as a fun or scary fact for science communication, but rather as an opportunity to frame the disconnect that I highlighted previously, the disconnect between those of us living outside the Arctic and those living within it. It can be framed in the context of climate justice or environmental justice, recognizing that our day-to-day actions that are contributing to the challenges of climate change are being disproportionately felt by Indigenous peoples living in the Arctic through the multitude of ways in which sea ice loss impacts their communities. And so as we look to the potential sea ice futures by 2050 or 2100, based on different carbon emission scenarios, we must face the realities of what sea ice loss will mean for global climate, for changing ecosystems, for new economic opportunities, and for the peoples of the Arctic. As we make decisions to pursue aggressive emission reduction strategies, or to essentially do nothing, we will see substantial differences in the amount of summer sea ice that exists at mid-century, or even greater differences by 2100. Collectively, we may choose to look at these types of model projections through a lens of climate justice. Sea ice is a defining characteristic of the Arctic, and as we heard from Maya, one of the best places to exemplify this is in the coastal waters off of Alaska. If we look to the Bering Sea, the last 2 winters have seen record low sea ice loss in winter. This is not all too surprising, given that Arctic sea ice loss across all months, not just September, correlates strongly with increased CO2 and rising global temperatures. However, the swiftness and scale of change observed in the Bering Sea region during these recent winters was a surprise. The region was mostly ice-free during the months of February and March, which hadn't occurred since at least 1850. The shaded gray portion shown here represents the modern satellite era, where we can peer into what sea ice cover in the Bering Sea has looked like on a daily basis. And so if we focus on this period, and define the envelope of what is average for the region across these last 40 years, we not only see that the last 2 winters, shown here by the black and red lines, are well outside of normal for these winter months, but we also see that large variability in ice coverage, variability that is experienced very differently depending on the community. Given the vast stretches of open water and the lack of protective shorefest ice, Bering Sea communities experience storm-related erosion, damage to village infrastructure, and lost access to critical ice-based hunting opportunities. Of course, the reason is more complicated than simply the ice is melting. For example, in these years, prolonged periods of sustained south wind helped to keep the ice further northward than usual. Yet it was the ongoing trend of thinning ice that made it more mobile in the first place. However, just as important as why this has been observed is what do we do about it? When a core component of the climate system, of the ecosystem, and of culture and food systems is rapidly diminished, we must focus on how to respond. In the Bering Sea region, it is very evident that the defining characteristics of winter are being disrupted. Perhaps another way to address the divide that I mentioned between the scales of how we understand sea ice loss is to consider a different model for how we communicate, how we tell the stories of change and of response at the local level. In the past, we have primarily shared stories shaped by science, complemented by the observations and knowledge of Indigenous peoples. We might now consider more and more looking at the model of stories shaped by communities on the front lines of change and complemented by the science. For example, the science being done by the climate modeling community. By stories, I'm referring to those that need to reach the decision makers who will put us on course either for no summer sea ice by the end of the century or perhaps on course for a stabilization in the sea ice cover. So finally, it is important to recognize that the observed seasonal loss of ice in the Bering Sea today and in other regions of the Arctic provides a glimpse into what it may mean for all of us to lose the majority of the entire summer Arctic sea ice cover in the coming decades. Sea ice is clearly not only a defining characteristic of the Arctic, but it is a defining characteristic of the entire Earth system. There are opportunities for those well outside the Arctic to learn from those who are experiencing the impacts of rapid environmental change and who know firsthand the range and decisions that must be made to balance competing interests and to respond to climate disruptions. So, thank you.
Thanks, Matt. Up next, Ted and Permafrost.
Thanks, Skiff. Well, I'm honored to be a part of this panel and a part of this conference. It's great to hear all the voices thinking about a changing Arctic. I'm going to try to answer 3 questions today for you, and I'm going to talk about permafrost, what it is, why it's changing, and why that matters to us. So this is a view from North Pole, looking at the northern hemisphere, and the area underlain by permafrost is colored here in blue. So permafrost underlies about a quarter of the land surface here, all of Arctic tundra in the northern boreal biome. Permafrost is perennially frozen ground, and if there's one thing that my colleagues will be happy about is if I can teach you that permafrost thaws, it doesn't melt. And the way to think about this is if you take some hamburger or maybe some moose meat out of the freezer, put it on the counter for dinner, you're waiting for that meat to thaw out, not for it to melt. Now, permafrost ground is the same way. It's made of ice, soil, and bedrock. This is a picture of ice-rich permafrost in Siberia, and the hill is actually eroded, so we're looking below ground here. There's a couple of features that I want to point out on this that will become important during my talk. First of all, we have this surface active layer. It's a few feet thick. In the summertime, it thaws, and then it refreezes in the winter. This is where the ecosystems are active. This is where plants, animals, and people depend on. Below that is the permafrost. It's perennially frozen. These whitish patches here are made up of segregated ice, big blocks of ice in the soil. This view here is about 2 stories high. These patches of ice shown sort of in 2-dimensional, actually form a 3-dimensional network within the soil here. Interspersed in this ice is permafrost soil with this organic matter. It's the remains of plants, animals, microbes that have all lived in these ecosystems, died, and become incorporated into the permafrost. So, unlike sea ice, unlike snow, unlike ice sheets, we don't have satellite detection of permafrost. So instead, permafrost is monitored through a network of boreholes. These boreholes are a series of pipes that go in the ground tens to hundreds of meters. And we know from this borehole network that permafrost temperatures are increasing globally. So this picture here showing the orange and red colors show increases in permafrost temperature over decades and years. Now, we heard from the last talk, and many of you might know that sea ice in September this year is coming very close to a record low condition. We probably won't beat 2012, but we're coming very close. But how many people in this audience know that permafrost temperatures are at record high conditions? So there's also green dots on this picture, and that's on this scale showing you a slower rate of change. So permafrost temperatures aren't going up as fast at these green boreholes. But this is actually indicating tipping points in the permafrost. Where temperature can't increase is because the ice in permafrost is actually changing to liquid water. And so these are these threshold changes that are undergoing these regions shown in green here. Okay, so what's causing permafrost to change? So we've already heard from this conference that temperatures in the Arctic are warming twice as fast as the global average. We know that we're setting new records all the time. Another consideration with permafrost is disturbances. Primarily in these permafrost ecosystems, wildfires are a disturbance that affects large land areas. Now, it turns out that fires burn down through the surface soil organic matter, and that acts as insulation for permafrost. So when you burn that away in a wildfire, it actually exposes the permafrost to the warmer atmospheric temperatures. Now, wildfires are part of some of these permafrost ecosystems, but we think that the area that's burning each year or the severity of these fires may be increasing. So yes, we've always had fires, but these fires are not the same as they used to be. So this is causing permafrost to change, but why do people care about this? We know that permafrost is defined by its temperature and time, and that's really defined the field of permafrost science for a long time. But from the perspective of people, I'm going to propose that we actually consider two other aspects of permafrost. That's the carbon that's frozen within it and also the ice, those things that I showed you in the picture earlier. Now, this might now be familiar from my talk that these are three components of permafrost. Excuse me. I'm going to go back one slide here. But if we think about our observation system, we're doing a lot in measuring with temperature, but observations of carbon and ice are lagging far behind. Okay, so why does this matter? So this is a picture of degrading ice wedges near Denali Park in Alaska. And what you can see here in this picture of a person for scale is that when the ground ice itself can melt and is removed from the permafrost soil, that the surface of the ground actually subsides. So you get this ground collapse. Now, why this is important is that once this process starts happening, the permafrost can thaw very quickly. And then where the ice is in the ground controls where the ground collapses. So you go through this threshold change that affects everything on the surface, the ecosystems and the people. So why do Arctic residents care about this? Well, these are pictures of infrastructure built on permafrost that's changing. And you can see the effect of the loss of the ground ice and the ground subsidence. From a scientific perspective, what would we like to know? Well, we want to figure out where is this ground ice. We have a hard time seeing it because it's underground. Can we figure out where these tipping points, these thresholds are going to happen and where we might have this abrupt thaw? Can engineering measures actually help us harden this infrastructure and prevent the kind of damage that we see here? So what does science have to say on these topics? Well, this is a map showing permafrost hazard for the permafrost region in these different colors. It turns out if we combine information on permafrost, on ground ice, and on future climate, we can overlay that with infrastructure. And this projection shows us that by 2050, about 33% of all global infrastructure in this northern zone is at risk. And this is under a moderate warming regime. Now, with a map like this, you can calculate these big numbers, but you can also zoom in on different regions. And so this is an inset looking at the Alaska pipeline here in white. And you can see that the pipeline crosses areas of low hazard and high hazard. So it's not all the same in the permafrost region. In a nice regional study by April Melvin, there was a calculation that within Alaska, if we continued on this high emissions scenario, business as usual, there could be up to $5.5 billion in climate-related damages by 2100. But science also has some solutions to this. So one thing we just heard about, reducing emissions globally, climate mitigation, can actually save money. We can reduce this cost by about a quarter through mitigation efforts. Through engineering adaptation, hardening the infrastructure that's in place, we can save about half of this. So there's things that we can do to prevent some of these costs. Okay, so that's a little bit about infrastructure in the permafrost region, and you can imagine that people live there, care a lot about what's happening to permafrost. In full disclosure, I own a cabin in Fairbanks, Alaska. It's built on permafrost. That permafrost is thawing. So every year I have to level my cabin and keep it from tipping over and ending up like those pictures up there. So I really care a lot about this issue. But if you think about people elsewhere, why should global society care about these changes that are happening in the Arctic? And the simple answer to that is that climate change itself might happen faster than we think. So the reason for that, and we've heard, is that what's happening in the Arctic doesn't just stay in the Arctic. And so there's this potential for a feedback loop between changing permafrost and warmer temperatures. So increasing greenhouse gas emissions that are happening globally, warming the Arctic, causing this permafrost thaw, that releases this organic carbon that's stored frozen. Microbes start to break this organic matter down. They release more carbon dioxide, more methane back to the atmosphere, and make this loop go around. So from the science perspective, what we want to know here is, well, how much of the carbon that's stored frozen is going to end up in the atmosphere? How fast is that going to happen? Will it happen over years and decades, centuries even? And will it come out as carbon dioxide and methane? These have two different impacts on the climate system. And finally, plants are growing more and they're taking up carbon dioxide from the atmosphere. So how much will this new plant growth actually offset the releases that are happening from the permafrost carbon? So what does science have to tell us about this? Well, it turns out some estimates show that maybe 5 to 15% of the permafrost carbon pool is vulnerable to release to the atmosphere by 2100 in a warming climate. Now, 10% doesn't sound like a big number, but because there's so much carbon stored frozen, that's equivalent to about 150 billion tons of CO2 in methane into the atmosphere. If you just normalize that to what's already in the atmosphere, that's equal to about 75 ppm CO2. If you go back to Kurt's talk on day one, he was talking about the glacial, interglacial period that just happened over the last thousands and tens and thousands of hundreds of thousands of years. The atmosphere was going between 180 and 280 ppm. It was moving 100 ppm and changing the Earth's climate dramatically. And you can look at what that is for context. So for other context, what's the rate that this carbon is going to be released from the permafrost region? Well, this rate, 150 billion tons over the next century, is equivalent to rates that are coming out of tropical deforestation today. So it's a similar biospheric change as we see with deforestation. It's much less than what's coming out from fossil fuels, of course. But if you think about global emissions treaties, we're trying to reduce these two sources. We're reducing land use change in the tropics. We're trying to reduce fossil fuel use. So any new additional source coming out of the Arctic is just making that much more difficult. Okay, so where are we? Some people think that the permafrost is already gone. Some people think that it's hopeless. But neither of those are true, actually. So this picture shows you some future projections for permafrost. And in blue here, we have a world where we reduce emissions globally. We kind of cap how warm the Earth gets. Red, we follow the current trend and do very little about it. And we can see that we can have an impact on permafrost. So limiting global warming to 2 degrees can save some of this permafrost. For example, if you look at 2050, the year that's the subject of this conference, if we reduced our emissions, we would save an additional 33% of the permafrost that would otherwise be lost by 2050. And that trend just continues as you go out further to the end of the century. A whopping 145% of the permafrost, this additional permafrost, can be saved if, again, we limit global warming. So my take-home message here is that even though we do see that permafrost will decline in the future, we can do something about this. It's going to be important for mitigation and adaptation for these actions to save infrastructure that's in the permafrost region currently, but really, truly, I think global mitigation is our best way to save the permafrost that we have now. Thank you very much.
Thanks, Ted. Twyla?
You've now heard about remarkable reductions in sea ice and extensive permafrost thaw across the Arctic, impacting ecosystems, human infrastructure and economies, human lives, and contributing to additional warming. Now we'll turn to a third component of the Arctic cryosphere, land ice, shown here in yellow. Arctic land ice includes glaciers across Russia, Scandinavia, Iceland, Svalbard, Canada, and the United States, as well as the Greenland ice sheet in Greenland. Across the Arctic, and indeed across the globe, we have seen a rapid acceleration in land ice loss over a very short period of time. Over the last several decades, the smaller glaciers around the world, including the Arctic and particularly Alaska, have been the largest land ice contributors to sea level rise. With Arctic land ice outside of Greenland containing enough ice to raise global sea levels an additional 9 inches, ongoing loss of ice across the US, Canada, Russia, and elsewhere will continue to be a major concern through 2050 and beyond. But just as alarming, or perhaps even more so, is the rapid increase in ice loss that has taken place in Greenland. The Greenland ice sheet sits atop the largest island in the world, and at the center of the ice sheet, the ice reaches more than 2 miles thick, equal to about 7 Empire State Buildings stacked on top of each other. The Greenland ice sheet was close to being in balance through the 1970s, 1980s, and early 1990s, gaining about as much mass through snow in winter as it was losing through melt in summer. But early in the 2000s, Greenland ice loss began to increase. And since then, we have seen a rapid acceleration in ice loss. For the last 20 years, Greenland has lost ice every year, and the amount lost has increased. This year, in 2019, ice loss from Greenland has so far been the second largest on record, with this type of record beginning in 1950. While Greenland contributed little to sea level rise before 2000, it is now adding as much water to our oceans as all of the world's smallest glaciers combined. But the reservoir of ice that Greenland contains and that it could contribute to sea level rise in the future is much larger. Greenland contains about 33 times more ice than all of the rest of the Arctic combined. Our scientific knowledge about how much ice Greenland and the Arctic contains and how much of it we are losing comes thanks to advanced technologies like NASA's ICESat and ICESat-2 satellites, which measure changes in the ice surface height, and NASA's GRACE and GRACE follow-on satellites, which measure the total mass of the ice and how it changes. Advances in remote and unmanned measurement technologies are also beginning to facilitate underwater observations so that we can examine where the land ice meets the ocean. What these measurements are telling us is sobering. We're losing unprecedented amounts of ice. Why is this happening? The big picture is that human-caused climate change is increasing air temperature and warming ocean waters. As air temperatures increase, there's more melt on the ice sheet surface. And the melt season becomes longer, beginning earlier in spring and stretching further into fall. There's no longer enough snow falling in winter to offset the large surface melt happening in summer. And once snow is lost from the ice sheet surface, the ice exposed and the lakes that form and streams that form on top of the ice sheet encourage more absorption of energy because they are dark. And they absorb this energy from the sun and create an amplifying cycle of additional melt. And around the edges of the ice sheet, the ice is in contact with the ocean. Ocean waters around Greenland are warming more rapidly below the surface, at about 600 to 1,000 feet depth. All around Greenland, large, fast-moving glaciers are acting as conveyor belts to move ice from the interior of the ice sheet to the ocean. Where these glaciers contact the ocean, warm water can increase the ice melt happening below the ocean surface. This increased melt can drive the glaciers back, causing retreat. In many instances, retreating glaciers speed up, allowing them to bring more ice to the ocean from the interior, and they pull the glacier, causing it to thin and become more susceptible to retreat, creating another amplifying cycle of ice loss. Together, warmer air and warmer oceans are creating a double whammy that removes ice from the ice sheet surface and from its edge. But simply observing this ice loss doesn't tell us about why we should care. For that, we need to look at the impacts of losing ice. And the impacts of losing land ice in the Arctic span from the local to the regional to the global. In Greenland or Alaska or other areas close to ice loss is transforming local ecosystems. As we lose ice, we put more cold, fresh water into the ocean and change the delivery of important nutrients. This changes the ecosystem, including in places where, for example, industrial fishing or subsistence hunting is important. Regionally, as we add this cold, fresh water to the ocean, we're also changing the character of the ocean water and influencing how currents move. The ocean currents don't simply transport water, they transport heat and energy as well. By moving heat and energy, changes in the ocean currents have the power to influence climate in Europe, the US, and other mid and low latitude countries. As we zoom out even further, loss of land ice across the Arctic is increasing sea levels around the globe. The impacts of sea level rise are wide-ranging and serious. As oceans rise, we see coastal erosion threatening houses and eating away at coastal environments. Salt water is able to inundate freshwater resources, and rising oceans can cause problems for stormwater systems, potentially disrupting clean water sources and increasing health concerns. And coastal areas around the world are seeing increased flooding. In some instances, areas are flooding permanently. Other regions are flooding more often, and rising waters are reaching areas that had never had to deal with flooding before. Across the US coast, we're already dealing with sea level rise. As we look to the future, it's certain that we will continue to lose ice across the Arctic. For example, the Barnes ice cap on Baffin Island will disappear within a millennia, even without additional climate warming. But the larger areas of ice, like Greenland, the amount of ice that will be lost in the future and how much seas will rise in the future is closely connected to human actions. In 2050, the difference in sea level rise that will occur if we follow a low emissions, which would require aggressive action, or a high emissions pathway, as we've been following so far, is just beginning to emerge. By 2100, a high emissions pathway that we've been following will create substantially higher sea levels. Unfortunately, research occurring right now on the behavior of ice sheets suggests that it may even be possible for the seas to rise more rapidly, perhaps approaching 6 meters or roughly 6 feet of average global sea level rise by 2100. As we create our global future, it is critical to recognize that the actions we take and the emissions pathway we embark on within just the next decade and the next couple of decades will have impacts that reverberate for hundreds of years. For Greenland, the result of taking a low emissions pathway, which you see here on the far left, remember that would require very aggressive global action, versus taking a high emissions pathway, the one you see here on the right that we're following right now, is the difference between substantial preservation of most of today's ice or total loss of the Greenland ice sheet within the next 1,000 years. We heard from Maya earlier about the long history of culture, oral traditions, and practices that have been developed by Indigenous people in Alaska and also across the Arctic. I think many of us might have come here feeling like 1,000 years is a long way into the future, but I hope that you can now appreciate that it's in fact a blink of an eye. So, as we consider the impacts that we're already seeing from Arctic ice loss, we must also remember that the severity of the impacts to come over hundreds of years depends on these next several decades of policy and decision making. It is not too strong to call this a climate emergency, and it falls on our shoulders to look at where we have personal influence with family, friends, organizations, and people making decisions on policies, from policy to business, and to find the ways that we can act and that we can require that they act. Thank you.
Thanks, Twyla. And now, David.
Thank you. Good morning, everyone. I'm going to build on Twyla's presentation a little bit and everybody else's. And I've been learning a tremendous amount here by leaning on the experience we're having in California. So my place in this tent is California. And I'm going to focus perhaps a little idiosyncratically on the challenges and some of the projections that we're using in California and in the West US in general. And I'm going to focus on sea level rise. And my goal in part is to frame the challenge, not really in terms of mitigation policy, which I'm not going to be touching on very much, but more what we need from science and the interaction between science, climate science and the projections that we use in our planning on a day-to-day basis and the challenges that we face in a place like California. Hopefully I can help answer the question that Marika Holland asked yesterday, which is, what do decision makers need from, I guess I should get my slides going here, from climate science? I'll try to answer that question. So we're in the midst now of understanding our vulnerability, and we're looking at how this vulnerability is going to play out over time and what the challenges are for policymakers in responding to that in real time. It's starting to get fairly real, even as we think along a kind of decadal pattern in terms of the worst impacts of sea level rise. This is a headline from a community called Del Mar on the California coast, Southern California and San Diego area. Managed retreat is already being discussed by a California regulatory body, and Del Mar is being asked to think about managed retreat in your long-term planning. Del Mar has said, no, thank you, we don't want to think about managed retreat. These are fairly large homes along the surface, along the shoreline. And so this is starting to play out already, even as the worst impacts that we're going to see, the kinds of things that Maya was talking about, are still quite a far distance in our future, at least. The adaptation challenge, not to trivialize it in any way, is significantly one for us related to dollars and money and costs. Eventually, we will be taxing our citizens to pay for adaptation. We'll be raising rates, we'll be instituting new fees, we'll be appropriating funding from various legislative bodies and from our tax resources. And that's ultimately one of the questions that we have to ask is at what time, what is the timing of that expenditure? What is the nature of that expenditure going to be? I don't think we're really going to put a tidal gate across the Golden Gate, and if we did, it would be a steal at $1 billion as the Rotterdam Gate cost in 2019 dollars. But it's the kind of challenge that people are already starting to talk about. At the same time, there's a lot of confusion about how to go about this business of adaptation. This is a new thing that we're all doing. And this is a word cloud from a meeting or from a session at the 2017 National Adaptation Forum, which is a conference that brings 1,000 adaptation professionals together. 45 of them were in this room and were asked the question, what words describe the current ecosystem of adaptation resilience services? This is a question related to the science, related to uncertainty, related to what kind of translation of the science and uncertainty are you getting? What are best practices in adaptation? How do we go about adapting to this reality and as it plays out? And you can see that there's a lot of confusion and dispersion of this information. Folks are not yet clear on how to do this work. And it's not getting better necessarily. In some ways, it's getting worse. So just to orient toward this slide to start, I'm going to use this a few times. We've got low, median, and high projections for sea level rise. This is 5 authoritative sources over a 5-year period that we've been using in California, starting with the National Research Council's 2012 report on Washington, Oregon, and California, National Climate Assessment, the 5th assessment report of the IPCC. This is the NOAA report that came out the last day of the Obama administration. And this is the Rising Seas in California report that was a commissioned report from a number of scientists by the state. What we're seeing in this trend is virtually no change in the median projections. They're all about at a meter in 2100. We saw some tables that showed that earlier today and yesterday. But a significant change in the upper end projections, nearly doubling between the NRC report of 2012, which was viewed as best available science at the time, to the Rising Seas report, nearly doubling. So from a high end of 5.5 feet to a high end of over 10 feet. This is challenging. This kind of gap, this kind of range is very challenging. It's not something we can't deal with. We have tools that can help us understand what the range of effects on us will be. This is inundation mapping for San Francisco shoreline, focuses on the bay side. The green areas, by the way, are disconnected. They're not going to flood. So 3 feet of sea level rise in San Francisco is not that significant. We're actually very fortunate. We have a decent grade line in a lot of our shoreline. 9 feet of sea level rise, however, is significant. And so this range that you saw on the previous slide is extremely impactful in terms of what the adaptation challenge is for us. And we're preparing for all of these futures. But let's talk about what we need next. So again, we've got, this is actually, this changed it a little bit. The blue bars are median, the orange bars are high-end projections, and then we have some extreme projections. These are the projections that we have under the different RCPs. And what's interesting about this, and this is trying to get to the question, what do decision makers need from science, is that the differences across emissions scenario for, just say the high end, are not that significant. 5.7 feet, 6.9 feet. This is 2100, this is 2150, so looking out quite far here, partly to get the contrast clear. But when you're looking at the differences within any given RCP, within any given concentration of greenhouse gases in the atmosphere, the differences, are quite significant. I'll get to that one in a second. So just to pick RCP 4.5 in 2100, Sea level rise could be 1.9 feet, it could be 5.9 feet. In RCP of 4.5. And so a partial answer to the question, very much a partial answer, what do we need from science is, can we narrow the range of projections? Within an RCP, not the political science of what emission scenarios we might be under in the future, but what can we do to narrow the range within any given emission scenario? Now, the difference in this scenario is that with the extreme sea level rise, the very, very high numbers, obviously we're seeing great sensitivity, and this is largely of land ice to RCP. So if you've got RCP 2.6, we don't have anything like the kind of catastrophic loss that we're seeing up here. And so obviously greenhouse gas emissions are extremely important in that situation. Not surprisingly, we're seeing a lot of different projections emerge in different jurisdictions. This is some preliminary research that we've done recently in San Francisco on 28 jurisdictions. I obscured the localities because this is still in review, and also because we haven't determined the degree to which vertical land motion is factored into these projections. But what you can see is a significant difference between the projections that are being used at the high end and projections that are being used at the low end by jurisdictions, in some cases the same ones. Here we've got California happens to be the highest, has the highest projections, but here's a jurisdiction in California that's using much lower numbers. Can we get better communication, collaboration between decision makers and between decision makers and scientists so that these kinds of differences are not quite as wide as they are now? Some differences are going to be merited because of a lot of different factors that contribute to sea level rise. But what else can we do? So I want to take one short case study, which is high-end sea level rise. As I mentioned, high-end sea level rise is a projection that's getting much, much higher over time, as opposed to median. And a big driver of that, for us at least, is Antarctica. And this is the Decano and Pollard paper from 2016 that does a number of things related to Antarctic catastrophic melt. Very important science, very interesting and important modeling that Decano and Pollard did. And it got a lot of attention because it really drove the projections of sea level rise in the 2100 period much, much higher than we've had before. It was actually the most cited article on climate change in social media and the news media of 2016. And it resulted in, among other things, some pretty significant increases in the projections at the high end. This is the source of the Rising Seas in California's projection at 10 feet in 2100, which is almost incomprehensible, is largely the Decano and Pollard paper from 2016. But there's a problem. It was experimental. It was a starting point. It's important and valuable, but it wasn't necessarily the final word. As we saw in 2019 when a new paper by Edwards et al. Came out and came up with a number of other theories that said that perhaps the Decano and Pollard projections for 2100 could be re-examined or should be re-examined. What we get then is another set of headlines that says that the terrifying prediction that we had 3 years ago is not necessarily still applicable, or we don't know yet. And so what we need is more discipline from the science community and the adaptation community working together to interpret new science and to be able to distinguish between cutting edge, peer review research that's extremely important, as the Decano and Pollard paper was, but also between that and actionable information. Science that's ready for application in the real world, where we're raising taxes, where we're raising fees, where we're instituting new costs to actually plan for decision making. I'm going to skip that one and go to a paper that just came out this year. A number of European sea level rise scientists participated in writing. They invited myself and Kate White from the Army Corps of Engineers to participate because the focus is on high-end, whoops, sorry, go backwards. How do you go backwards? There we go. High-end sea level rise for stakeholder applications. And this paper came up with a framework. It's not the final answer at all, but it's a framework that looks at lines of evidence from strong to weak that should influence decision-making in that way, and looking at plausible worst-case scenarios, which may not be planning projections, but things that you should be thinking about as possibly occurring in the future. This is the kind of discipline that I think can help us to frame the adaptation challenge in an appropriate and timely way, rather than responding to every new study that comes out. It's not that we can't make decisions under uncertainty, as I said. We're prepared to do that. That's part of it. Nobody in my community is asking for a single number. And we understand that these decision points today are different than the decision points that we're going to have tomorrow. We're going to have uncertainty. And we understand that. But can we narrow the range of uncertainty to the extent that planning becomes an easier exercise? This isn't the kind of tragedy that Maya alluded to in her talk. This is the beginning of things. This is Miami a week ago, before any rain, before any precipitation came down. This is nuisance flooding, but it's part of the future that we're all going to face, and it's going to get a lot worse than this. My goal is for us to work together across the adaptation enterprise and then with the science community so that we can respond together. Thank you.
Thanks for those great talks. And this is perhaps the best part, right? Because we've had an opportunity to hear from 5 folks, and now we get to hear from all of you. For those that weren't here yesterday, we do have an app that allows you to ask questions through this device, and then I'll say them. Slido, and that information is up there. If you haven't downloaded the app, feel free to take advantage of some folks that are wandering around, and you could write questions on.
Don't need to download anything. You just do it online.
You could just do it online. Okay, there you go. And there's also the index cards that are going around for those that like the old school paper and pen route. So with that, a number of questions have already come up. And this first question is for you, Maya. You highlighted in a very personal story the very desperate situation for a lot of the people in Alaska. And before this session, you talked about how you actually possess all 3 hats that are represented here in this conference, as a researcher scientist, as a traditional knowledge holder, and as a decision maker. So as a decision maker, how do you think about or start to address the very situation that you presented?
As a decision maker?
Yeah, what are some of the tools in your toolbox that you can put towards the situation?
Climate situation?
Yeah, sure. Okay, yeah, I know.
mean,
It's a big question. And
It's
Brendan,
kind of a broad question. I think as a superintendent, I'm going to plug the Park Service here. The Alaska region of the National Park Service has several Indigenous superintendents, which puts Indigenous people from that area in a decision-making seat, or adds another layer of experience when we make decisions. And so I can't speak for any other superintendents or anybody who's come before me, but just speaking as a superintendent for Western Arctic National Parklands, because I have the experience and because I have the history of understanding what safe ice looks like, we just do things like don't take risks on, yes, it's cost $60 for a snow machine ride from Kotzebue to the Anigak Ranger Station, but there's a patch over here that traditionally we wouldn't cross even with a dog team, so I don't want my staff to cross that. Therefore, we're gonna charter an airplane and you guys are gonna fly there. And sometimes, if you don't have that, I guess, Indigenous knowledge combined with scientific knowledge, I think if there was a scientist there, they would say, don't cross that ice.
Sure, yeah.
Then some people might, think it's not a good use of public funds to take an airplane, but I'd rather stay safe and have my staff completely safe rather than take any chances, I guess.
Well, no, yeah, that's definitely something that I think we could all agree on, is that human life is what we're trying to protect,
Right.
And so I think that would be a good use of public funds, or I'd certainly be happy to contribute to that.
Yeah, and I don't know what, I mean, I'm not sure what I don't know what the background of the question is, kind of broad, but, like I said, I'm from 67 degrees north. So, like I said before, the climate crisis is today. We feel it every single day. You don't have to be an Indigenous person to feel it. If you live in Kotzebue or you live in any of the surrounding communities, you feel it every single day. And you don't necessarily have to be related to anybody to, hear about anything. It's such a small, tight-knit place that no matter what, you're going to hear about it. It's going to affect you, or it'll affect your children, or it'll affect your family members.
Right. So maybe in that vein, and because of the limit in characters, there isn't much background to the question, but, does this sort of underscore then in your mind the importance of delivering that story in sort of chorus with other, like either science knowledge and other traditional knowledge to try and talk to policymakers to act on climate? Or
Political question.
Oh, right, sorry.
I mean, it's really important, I think, to make it to make it personal and make people understand. There was the last slide was Miami is flooding, and we've been having flooding for 10 years at least. And so Alaska, rural Alaska especially, doesn't have a lot of representation in the worldwide media unless, a president visits or something like that. But so it's important to make it personal so people can understand the importance today, right now. We're not talking about 2050 in Kotzebue, we're talking about what are we going to do today?
Well, that's very relevant. And I think that's an important message to make it personal. Another question that has come in is in reference to a comment that you made, David, regarding the range of sea level rise predictions, for example. So like sort of asking the science community to try and narrow that. So to try and turn this into a twofold question, for David initially, do you think you can represent what that range would be for a politician to be able to make that informed choice? Like if a politician were to say, if you can get it to here, this is where I could say, yes, more money, or no, I'll sit until the next election or something like that. And then maybe to the science knowledge and traditional knowledge holders here, like, what are some of the ways that you might imagine being able to refine the products or the communication that you're giving to policymakers? But we'll start with David first.
So the answer to that question is no, not really. There's no desire on my part. I wasn't trying to indicate at all that we need to fit projections into some kind of scale that we can work with. That's not the case. We want those projections to fit into a scale that is as accurate, whatever that means, about the future in a non-stationary world as possible. And I think that the greater discipline for high-end sea level rise is one of the areas that we can focus on. And understanding the sensitivity of land ice, for the most part, Greenland and Antarctica, to melting, continuing to improve what we understand there, because that's the biggest uncertainties as you get out later in the century. In 2050, I didn't show 2050 numbers, but the projections in 2050 are something like 8 to 24 inches, depends on what source you're looking at, under no RCPs at all, because we're not sensitive to emissions between now and 2050 for the most part, although sometimes that's changing. 8 to 24 inches itself is a fairly wide range. So it's not that we can't handle a range, as I said, and it's not that we want a certain kind of range. We just want it to be as narrowed and carefully constructed from an actionable science perspective. This has nothing to do with cutting-edge peer-reviewed science, but from an actionable science perspective as possible, so that we can frame to our decision makers this range as a challenge that we can work with. In the 2012 report for the NRC, it was 3 to 5.5 feet. That's significant, but workable. Now, we're still at 3 feet in 2100 as a median projection, as a most likely projection. using the models, but we're at this much, much higher number at the higher end. So is that necessary? If it is, we'll have to work with it. If it's not, let's make sure that we're providing translated science for a decision, in the decision context that is as state-of-the-art as we can get.
And maybe just hooking on that term you used of actionable science, does anyone here have any sort of like just initial thoughts related to David's response?
Well, speaking towards the land ice, which is of course a major contributor to sea level rise, this is something that the glaciological community is thinking about a lot, and I work with David in other contexts to try to connect our communities. But the understanding and exploration of how large ice sheets change is a fairly young scientific field with a somewhat small group of scientists working on it. And I would say everyone's doing their best to run at marathon pace because we all can understand deeply how important this is, and that we're trying to understand how rapidly a system can change while it is changing rapidly. And I think one of my biggest concerns is that any decision makers will wait, that they'll put off making decisions in an attempt to get numbers that are better defined. And I think that would really be a shame. And so what we're trying to do is find ways that we can work with decision makers to better represent what we do know while making progress on these outstanding questions that play into those very high projection numbers. So it's an area of need and an area where I think more attention is growing, but that will have to continue.
And maybe I'll just chime in from a related idea, but I liked seeing the paper that you were a part of, Dave, that had yourself and other scientists as co-authors, because it seemed like this definition of actionable science, it's hard for it to come only from the science community. And so part of why I'm here and why many people are here is to build these bridges and think about how do we deal with that. And it seemed like from the title of that paper, you guys were taking these high-end estimates, the ones that cause trouble for decision making, and trying to kind of weed through that and understand how to act in the face of this uncertainty. And you left with that slide and that term of deep uncertainty, which I've become familiar with recently. And the whole idea with that, I believe, is that we must take action when we don't know the future. And so how do we have strategies to do this? And part of it might be doing what you suggested, looking at these high-end numbers, but try to systematically go through them and ask which ones we need to react to sooner and which ones we don't. And I think in the end, a partnership between people trying to make those decisions and scientists and folks living with the impacts is going to be, sort of maximize that.
And I think just to add very quickly, the concept climate services was in the word cloud, but I didn't go into it. It's the place where scientists and decision makers interact. It's the place where translation occurs. I've spent a lot of time executing our own climate services for San Francisco with scientists that I work with. It's an evolving relationship. We can do it better. We can invest in it more. It can occur, very separately from the cutting edge science work that is extremely important and got us to where we are today. And in addition to that, with boundary spanners and decision makers who appreciate the value of science, and scientists who are interested in working directly with decision makers, which is something like 5% of the total scientific community, or less, and that's fine. We have to evolve that practice, however, in this country more quickly and better than we've done to date, in my view.
I would just argue as a scientist that there's probably more than 5% that are interested, but we don't have the training or the tools or the fora to do that.
Or the incentive structures within academia.
Right, and that was touched upon yesterday, so that's definitely a great callback to some of the discussion yesterday. And I'm going to interject because a lot of this response touches on a couple of questions, so I'm going to try and distill them. But so to your point about having opportunities to have decision makers, scientists, modelers, engineers, in the same room. One half of the question is, how have you seen that work well in the past, being in the same room and actually delving in on a topic that's very specific? And then the other half of the question, which is a little bit of a pullout, and I might have to ask it again, I realize, but is where have you all experienced success in being able to communicate what you thought was the important takeaway, actionable science or actionable knowledge to help inform policy? But maybe starting with this very, like what you touched on, like, are there active venues that allow for this,
So it works extremely well when pursued seriously. The downside is that it's very labor intensive. It takes a lot of time, and the amount of times that the word co-production has come up in the last day plus has been very gratifying for me and will be when I report it to my colleagues, because the concept is entering the lexicon, and that's a good thing. And it basically means a little what Marika said yesterday. What do decision makers need from science? Or what do decision makers need right now? What are the questions that we're asking? And how can we pursue those questions using best available science? That dynamic can be very successful. Did I just cut off?
Perhaps.
I'm back? Okay. That dynamic can be very successful when both parties are interested in pursuing it and sustaining it. I'm actually part of the literature on how to for co-production of actionable science. Paul Beyer, one of your colleagues, was the lead author on in Conservation Letters. There's lots of literature on this, but and there's lots of literature on the disincentives for this to actually occur. Scientists don't want to be seen as consultants. Decision makers don't really reach out for PhD scientists in our everyday work frequently or at all. But in this brave new world that we're in, it can work, and it is being pursued more and more. The RISA program that NOAA's funded for 20 years has a series of locations, regional integrated sciences and assessments. They all have their own idiosyncratic branding, but there are entities that have worked very closely with decision makers and done some extremely valuable work. The Climate Adaptation Science Centers that the Department of Interior funds are also great examples of that on the ecosystem side. So it can work.
Are there observations on where it has worked in some of the other panelists' experiences? Okay, I'll take that as an answer. That's pretty shocking. No, but I think that points to how there needs to be more mechanisms, and how can we change the, again, reward structures to provide opportunities besides just conferences where we can all be in the same place at the same time. Bringing it back to Maya, there's a couple of questions here, but I think we can start with you and then go on down the panel. Some of the questions are involved with timescales. So how far out should we plan? You had mentioned that these are things that are happening 2019, not 2050. And then particular for you, someone had asked about, have you seen ways where this message of the experience of rural Alaska communicated successfully to, say, the rest of the US? So it's specific to us, but how can, the question is sort of wondering, how can rural Alaska or Arctic Alaska engage in a sustainable manner that reaches down to the rest of the country?
How can rural Alaska engage in a sustainable manner?
Or with the message, I
mean, we tell the message all the time. People just need to listen to it.
Okay. There you go.
I mean, so, and I think you answered the first question yourself, what's the timeline? The timeline is today. Unfortunately, rural Alaska is very underrepresented in policy and decision makers, and things like that. I'll just leave it at that. But fortunately, we're also a very small, Alaska is a very large state, but we're a very small, we feel like a very small state because we're family. And so, the issues that are happening in Northwest Alaska are also happening in Western Alaska and Southwestern Alaska and Southeastern Alaska and Northern Alaska and Interior Alaska. So the situations that are taking place in Kotzebue and the surrounding communities are taking place everywhere. And if you're not on the coast, it's river erosion, but the loss of cultural resources and the loss of subsistence resources and food security, that's taking place every single day. I think a lot of times it comes down to money. How much money are we spending to mitigate these things? And so in rural Alaska and Kotzebue, just as an example, because that's the example I know, we built a seawall and it was 4,400 linear feet and it was $44 million. So it's $1 million per 100 feet. And so as long as, I think if we put the money side into, policymakers and decision makers' laps, and we say, if we don't mitigate something right now, in 10 years, it's going to cost, $60 million just to fix this. And maybe there's a better way if you just listen to the people who have been saying this, there's a better way.
There's a better way, okay. I think, and this touches on previous to yesterday, this idea of storytelling and just continuing to tell stories, and you sort of highlighted how personal stories in particular are really effective. Twyla?
Yeah, I wanted to go back to your previous question, and also thinking about Maya bringing up these different costs. Search, putting on this meeting, I think has been trying hard to explore ways that we form and foster successful examples of people getting together, and has worked with, I hope people have looked at the policy briefs that have been, 2 pages, meant to be something that gets in front of a policymaker and it helps explain the science, or bringing people together. And I know from our experience on the Land Ice Action Team, we really had to, in part, discover all of the communities that we don't know about. So as we thought, well, instead of trying to find decision makers that might come to the American Geophysical Union meeting, which is where all of our science colleagues get together, we should look where these decision makers, where are they getting together, and we can go find them. And we had a period of challenge just to find the right people in that community who could tell us where they get together. We have a lot of separate spheres, so it can sometimes seem like we're saying a lot of things, but it takes actually a lot of hard work to get into these other spheres that are themselves contained. And one of the challenges in having people brought together is the support for all of the people to be there, and not just support so that people could travel and be in one place for a workshop, but support for the hours and salaries of those people to put in the work before and after they're getting together. And funding sources can be really siloed in the U.S., and that can be a big challenge. And also, as we heard yesterday, and I think even just so far this morning, a lot of these connections require long-term relationships, and show success. There we go. Being able to show success over very short periods of time, a handful of years, which is often what we on the science need to do for grants, is a real challenge in this space. Often success comes over, many years. So those are some of the challenges, and I think luckily conversations and connections are being formed so that we can move further along that line.
Thank you for that. We are kind of running out of time. I want to say that obviously I didn't get to all of the questions here, but I think on some level that's a great note to end on, is focusing on the opportunity to build on the relationships, bringing in some of the different stakeholders, with the understanding that there are many stakeholders that could also be at this table Some of the questions pointed out, like, if the stage was bigger, we could have social scientists and engineers and medical doctors and, any number of voices to help bring this forward. But with that, I would like to thank the panelists for their time up here. And so since I'm on stage and my voice is still droning onward, I want to point out that there is a coffee and tea break to build on what Twyla suggested. Build a relationship, meet someone new, down some caffeine, and then we are back in this room at 10:30 to hear about Indigenous knowledge approaches to informing policy. So thank you very much.
Thank you. Let's get started again. So here to introduce this topic and the panelists, I think it's going to be Rochelle or Melinda. Which one of you is going to do? Rochelle?
I'm going to start, yeah.
So Rochelle Daniel. Rochelle's with the Pew Trust for the Environment, and she's also on the Science Steering Committee for Search, and she has a million other things she does. And she and several of the people here on this panel have led the effort to really involve Indigenous people in this meeting in a meaningful way. Rochelle?
Great, thank you. So Melinda and I are co-facilitating, but we'd like the Indigenous Peoples Working Group to stand up to be recognized because this panel was very collaborative and it's been a group effort. So please, Corey, Nikush, Julie, please, all of you folks stand up and be recognized. And so before we move on, we would also like to thank Maya Lucan in the last panel, for talking about tragedies and how tragedies impact our lives and how we can relate to them. And we'd like to also take a moment just to acknowledge and to have in our thoughts the folks in the Bahamas who are experiencing a tragedy born out of their environment, and now they're dealing with the aftermath of that tragedy. And so as Indigenous peoples, we relate to the environment and we face these tragedies all the time. And so we just wanted to take that recognition before we start. And so the other thing, some of the challenges that, we faced in bringing this panel together, reflect the challenges that as Indigenous peoples, we face, in our daily lives. And one of the panelists experienced weather delays, fog in Savunga. And, that's representative of our transportation and weather-related, challenges we increasingly face. Another panelist responded to the loss of one of our young regional leaders. And so as Indigenous peoples, working in the forefront of all these issues on these different fronts, we face many, critical issues, but we also have to decide on, where we put our time and our effort. And we have to make choices, and we really support the choice, of Charlene Stern to be with her region and her family. And so regarding family, I think it's really important to all of us as Indigenous peoples, and we all engage our family in these issues. And so we'd like to share that that Denali, one of our panelists, is also the daughter of Melinda, one of our co-facilitators. And Indigenous Working Group also felt the importance of having the youth voice. And so this panel, building off from what Daly said yesterday, Daly talked about our worldview. What's our worldview? And we're a part of the ecosystem. We see ourselves that way. And she also talked about co-production of knowledge and bringing equitably Indigenous worldviews and science or policy together. And so our panel here is going to help inform by their experiences, what does that equity look like and how do we build that equity? And so please see their full biographies in your handout. But really briefly, I'm just gonna say a sentence or two about everybody because they're wonderful people. So George Nungluk is St. Lawrence Island Yupik, Indigenous knowledge holder, and he'll share, what's Indigenous knowledge mean as a St. Lawrence Island Yupik. Austin Amasak is from Nome and will share his experiences working in policy and trying to bring regional perspectives to the federal level and international level. And then Denali Hodgson spent last spring semester as an intern at the Wilson Center Polar Initiative, and then commercial fishing in Bristol Bay. And so she's gonna, share her vision. What's 2050 look like for, a young Indigenous person strongly grounded in her culture? And so George is going to start off. So George, the floor is yours.
Thank you. Thank you for having me. I really appreciate being here so I can be able to tell a few stories about why we do things the way we do. And from time immemorial, several millennia back. But our activities, on subsistence fishing, subsistence hunting, gathering is all based on knowledge that was given to you by your forefathers. And I think most importantly, is the location of where you conduct your subsistence hunt and gather food is based on that information and how it can save you time and energy, because without those, you won't have much energy left trying to get to your subsistence activities. But St. Lawrence Island happens to be in a location where marine mammals migrate en masse. I mean, this is the corridor, the Bering Strait, Chukchi Sea, and the Beaufort Sea contains the world's richest marine mammal migration ever in the whole world. So we're really fortunate to have been located within that area, so we can spend less time, less energy to obtain what you need to feed your whole community. Not only that, it helps you to get along with people. It helps you to observe and protect what you have. You want to be able to do that because you have grandchildren and children that you really love. And to do that, you must be able to protect that realm so they can enjoy the same pride, same energy, same food that we're experiencing right now. So it does provide, culturally, nutritionally, it's economic, spiritual benefits to all of our people, this activity. And if you look at the history of where the settlements around St. Lawrence Island are, all those settlements are within a few. They don't have to go very far to get the food. They don't have to expend as much energy to obtain the food. So it gives them the benefits, that added benefits to be able to cooperate and share. The cooperating and sharing of your resources is the key to our survival, has been the key to our survival all this millennia. So if we continue doing that, your children and grandchildren is going to be able to have the same benefits and experience that you're having right now. And even with all the changes that are happening within our regions, we always look for opportunities. We get to the high points. We have men looking every day, pretty much looking for opportunities. And from that opportunities, from that observations, we've been able to adapt to changes that are happening. Some of them are negative, but for example, we were able to create a new whaling season based on the changes in observation. And that was the winter whaling season. And by far, I think maybe through history, our activities in whaling were conducted in springtime. But now it's shifted to winter. It was the last 2 years, 2016, 2017, we didn't see any ice in St. Lawrence Island for 2 years. In the spring, summer, fall, winter, there was no ice. But even with that, without the ice, we were able to provide nutrition, provide spiritual health, provide that realm based on observations, based on adaptation to what you have, because without that observation, without the cooperation and sharing of knowledge that it's happening even with those changes, you are practicing a way for your children and grandchildren to adapt to changes. So those are very important. I think maybe even down the road, I think we'll be able to see how important everything is interconnected. You'll be able to see the stars, to see the whole ecosystem, how it's all interconnected. And the most important one is the oceans. We call the oceans imak. Imak means contents. Everything the ocean provides, nutrition to lots of people. 50% of American citizens eat seafood from the Bering Strait, Bering Sea. So all of you should be able to think about doing our part to protect that realm of ocean, because it provides not only to us, but everybody in this world. If we can practice not to pollute it, practice not to take care of it, don't trash it, I think maybe we can go a long way. Because the way things are going, sea level is rising, and the ocean's going to take you away if you don't take care of it. So, thank you very much for having me.
Thank you, George. And Austin?
Well, thank you. Good morning. I'm very happy to be here. And good morning to folks back in Alaska who are maybe listening in at the 6 o'clock hour. I work for COERC in their Marine program. In 2014, COERC established the Marine program to address some very severe issues related to increased shipping, to address some very severe issues related to climate change. And the Marine program started off very quickly with workshops in the region to understand and collaborate with the U.S. Coast Guard, U.S. Army Corps of Engineers, NOAA, NIMS, U.S. Fish and Wildlife Service, as many federal and state agencies as we possibly could to address what we considered and what we do consider some very severe impacts that we've already seen, that we've already experienced from increased shipping. Over the first couple years that the program existed, we made some findings, and we made some very strong policy stances on shipping. If you want to know more about what the COERC Marine Program has been doing related to shipping, of course, you can go to our website, coerc.org. You can search, Google search COERC Marine Program, and it should bring you straight to our Marine Program webpage. There we have our policy letters, our comments, our concerns, our various reports that we've done over those first couple years that the Marine Program existed. And I urge you to look those up or contact me. In those first couple years, what we found was that communities were very concerned about impacts to communities, how communities are changing because of shipping, how communities are very concerned about impacts to marine mammals, the marine environment from shipping. And then another aspect, a third aspect that we found early on and that we're still working on is the nature of discharge from shipping, whether it's gray water, black water, sewage, oily wastes, and very importantly for our region, the potential for oil spills as a result of increased shipping. In our region, we are not very well prepared for impacts of vessel discharge. Less than half of our communities have any kind of significant oil spill response equipment. Essentially, NOAA and Unalclete have skimmers, have suckers. The rest of the communities that do have something, the handful, essentially just have absorbent pads. A couple years into the program, in 2016, it became really evident how shipping is changing. In August 2016, the Crystal Serenity visited our region. And up to that point, I had been involved in tabletop exercise as well as communications related to that first voyage of a very large cruise ship to our region. And during the tabletop exercise and during the ramp up to its arrival, we were told that it would be escorted by an escort vessel, the Ernest Shackleton. And so in August 2016, it was a foggy day. I drove to the port and watched it come over the horizon, and I was very concerned and very interested as to where the Shackleton was, the escort vessel, which we were told would be accompanying the Crystal Serenity. I never saw it. It was foggy, and I thought, oh, maybe it stayed offshore. So I went back to the office to look and see where the escort vessel was. It was on the other side of the globe in the Canadian archipelago. So the concerns that we have related to preparedness, the concerns that we have about vessels, we think that they're serious. We think that they're real, and we're trying to engage. We are engaging in manners that involve local advocacy, statewide advocacy, national advocacy, and international advocacy. So my job takes me throughout the world. Fortunately, my colleagues in region have also been at the table of advocacy, we call it, locally, nationally, and internationally. But it is very difficult. Dealing with international organizations on the issue of shipping is extremely complex. Vessels, the issue of vessels involves many aspects, from one part of the horizon to the other part of the horizon. Vessel paint, vessel propellers, vessel discharge, the 40 or so sources of discharge that vessels have. These extraordinarily complex issues. Lately, over the last couple years, the Marine program has been working to try to implement some of the ideas that have come from our workshops, namely the carriage and usage of heavy fuel oil, which we addressed in partnership with ENGOs internationally to seek the ban of heavy fuel oil in the Arctic, the usage of heavy fuel oil in the Arctic. Also lately addressing issues of gray water, black water, and sewage discharge in the Arctic. And as Melanie mentioned yesterday, some advocacy on navigation, which we worked pretty heavily with and very hard on with the U.S. Coast Guard Port Access Route Study, as well as the International Maritime Port Access Route Study, and those areas to be avoided. In the next several years, in the future, the region is looking towards establishing itself in the realm of shipping. In the last year, COAR withdrew from the Arctic Waterways Safety Committee. We want a much stronger role, a much more direct role in how shipping is managed in our region. We take to heart the words that are said about our community from politicians who say they want to see and they want to ensure that local concerns are heard, local communities are heard, and their views are expressed. In our region, we do believe that we need to be able to put a barrier at the Bering Strait. Our ancestral waters, our waters are ours, as George mentioned. We're very concerned about what's happening to our region. If the politicians, truly believe in local community and local involvement, then that should be part of the discussion. Maybe we can't get there, but it should at least be part of the contrasting voices that are heard in Washington, D.C. about shipping in the Arctic. Thank you.
Denali Hodgins, the Ezra.
in which Washington, D.C. land was taken from, and also acknowledging the African American people that built the foundations of Washington, D.C. I'm a commercial fisherwoman in Bristol Bay, Alaska. I commercial fish in order to, one, have a relationship with the fish in our area, as well as to bring home money so that I can survive in a mixed economy in which I have to be paying for school, and I also have to be contributing to, fuel in the wintertime and other ways of living in Arctic life. As a commercial fisherwoman this summer, I was able to witness, and unfortunately had to witness, fish die off in our waters. The temperatures in Bristol Bay exceeded 68 degrees on some days in the water. I saw ghost fish in drifts. I saw them come up over our reel, and it was not because of the excess amount of drift gill netters out in our waters. It was because of increased temperatures of the ocean. I also, while I was out there, was reflecting on what it meant to be a commercial fisherwoman, and what it means to have to live within this mixed economy. And what I realized as I saw ghost fish drift by was that I want to be set netting. I want a balanced lifestyle. I want a lifestyle where I can be picking fish and earning an income and having that relationship with this animal at the same time that I can go out onto the tundra and pick berries, because I miss the best salmon berry picking year that we have seen in 5-10 years. Oh, thank you. Hello? Is that better? I want this balanced lifestyle because this is the lifestyle that my ancestors have been able to live up until 1492 and beyond. I want this lifestyle because this is what it means to be Indigenous. It's what it means to be an Indigenous woman. I want to be able to fillet fish, and I want to be able to pick berries. I want to be able to tan moose hides, and I want to be able to go out hunting for caribou. Oftentimes, I'm not able to go out hunting, mostly because I'm here finishing my education at Brown University, where I study anthropology and public policy. As we look towards co-production, whether it's co-production in the sciences or it's co-production across policy making and decision making, I don't just want a seat at the table. I want our young people to be the Indigenous scientists. I want our young people to be the Indigenous policymakers. I want us at the table with our voices heard, acknowledged, and there. And I want us to be able to stand up and speak our truth without fear of being looked down on, without fear of continued colonization, because yes, we still live in a colonized world. Alaska, right now in Bristol Bay, we are facing Pebble Mine and the implications of what Pebble Mine will do to our salmon resources. And right now, as we look towards the future and as we make policies as scientists and as people and as citizens, we must look towards a future that has green energy and not green colonialism, as we were talking about yesterday. We must look at it through an equitable lens. And what does equity look like? It means equality and the opportunity for all peoples to have a future. As we look towards co-production, what does that mean, and why must we have it? Why must an Indigenous voice be at the table? An Indigenous voice must be at the table because we know what it means to live in relation and see ourselves as a part, not as the top of that hierarchy, but as a part of the ecosystems that we are trying to save, that we are trying to manage, that we are trying to coexist with. So as we step into the future, I want us, and I expect that seat at the table. And I think as a young person, and as looking towards Arctic Futures 2050, I don't know if I'm going to be able to, or if my grandchildren will be able to fillet fish. I don't know at this point if we will have a good berry year. Every single season, to me right now, is important. And because of that, I think we need to be able to imagine those futures. And part of imagining those futures is having us here, right now, and having you actually listen, and having people dig deep down and be able to unsettle what it means to live in a capitalist society, and what it means to live in a society that has been built on resource extraction. Dogaden.
Well, we certainly are privileged to have this range of voices that represent us as people. You can see there are a wide range of voices. They represent Alaska, they represent the Arctic, and as many of you are here to have conversations with us, know that these conversations may not be easy. They may be tough. They may be a space where we expand on our history, because we also know that there's many of you that need to hear our history. It's not an easy place to be as you hear the voice of our youth say what is in our future, and look at these big complex proposals like Pebble Mine that we are looking at in the biggest wild salmon arena in the world. And then you have our elder who is challenging us to look at the choices we're making individually and how do we take care of our oceans. So to that end, I want to ask George, because you have, I just want to say I'm going to ask this question because we have a few questions that our Indigenous group asked us to start off with, and then we'll move into the questions from the audience. So George, you talked about our reciprocal relationship with the land and particularly with the ocean. And then can you speak more about what kind of information and solutions that need to move both ways between us as Indigenous people and the science, and in addition, the policymakers? Do you need me to expand more? Did you hear me, George? Oh, I'm sorry. Can you, I don't know if this is working, can you talk more about the reciprocal relationship, or how we need to share, what kind of information and solutions we need to be moving between or among policymakers and our Indigenous people and scientists?
Yeah, I'm sorry. I'm really hard of hearing, so you have to yell at me sometimes with your grandchild. But interrelationship, interconnection has to do with being able to work together. So I think maybe when you practice that realm, I think maybe you're going to be a lot better off in terms of survival, in terms of providing sustenance, in terms of providing the living, your living being, being able to be happy, being able to interrelate with your kids and grandkids. I think maybe that's the most important thing that all of us do in this world, is to take care. And to be able to take care of each other in that sense, I think maybe it allows people to work together and to cooperate willingly and freely. So it's a really important aspect to be able to obtain that relationship by working together and give that reciprocity. I think maybe you being able to, if you do that, you're going to get gifts from other members of your community. So in that sense, I think maybe it's sharing of these important resources, be able to get along with people. I think maybe it's the key to be happy, to obtain that feeling of accomplishment, feeling of getting, being able to be socially responsible. I think maybe those aspects are really important if you want to continue living a life that is most pleasing to you. I think maybe that's the most important thing.
Thank you, George. And my question, moving from our elder, I'm going to go to our youth. And this question is for Denali because you spoke so passionately about needing that seat at the table. And I also wanted to acknowledge a comment from the audience, from Daryl John from Guigalngok, Alaska, that speaks also towards your passion. And he states that there's a difference in rural policy and urban policy, that rural policy will not work in urban areas and urban policy will not work in rural areas. Tribal community leaders need to be involved when it comes to developing rural policies. And so my question for you, Denali, is, having the capacity, to engage in research or policy processes, and having the ability at a young age to be able to engage in those processes. Many youth from Western-based communities have a jump start in going to university and being able to participate in conferences like this as students and giving posters and talks. And so what support do you need to bring that Indigenous youth voice, to be able to participate in these, Western processes? And what might our institutions look like so that there is a seat at the table?
I think First and foremost, I think you need to go to the youth, and we will not know the opportunities that we have available until we are able to see the opportunities and experience the opportunities as well. I think that's kind of the catch-22 of being a youth or a marginalized person in this country, is that we don't know those opportunities until they are presented to us. And then when they are presented, we might have a voice and we might not be able to necessarily say what we need to say when we are brought into spaces like this. So one, I want to say, Dogaden, thank you very much for allowing me to speak today, because like we acknowledged, there aren't a lot of youth here, and are they on this stage? Maybe not. Which is a tough conversation that, again, we also need to be engaging in. I had the opportunity of coming to Washington, D.C. last semester through my university, and I will say that I would not be able to go to a university on the East Coast without having a full scholarship, which I am very, very grateful for. And yet that opportunity was presented to me because I was able to take a risk in high school and apply to an institution on the East Coast. I think when we are brought, it's a difficult question. And when we're brought into these spaces, I guess what I want to say is, how do you become a mentor? How do you become a mentor across cultures? How do you become a mentor across continents? And I think part of that is, one, as a mentor, if you are from the East Coast or you're from Washington, D.C., it's learning about that young person's home area, not just from that young person, but doing your own research as well. Being able to engage in conversation with them, and I say with them because it's not always to them. It's being able to bring that young person to the table and say, what are your ideas on this? What experiences that you have, and not just Western academic experiences, not just high school social studies, not just high school biology. What is your experience on the land? And also realizing that when our young people hold our silence, or we are quiet, or we might not necessarily engage in a space like this, that is okay. We have to be able to consent to sharing our knowledge as well. And when we hold back, and when we decide to raise our voice, then it's time to listen. Yeah. Thank you.
Thank you, Janelle. Look at him. I want to wrap one of our questions in part with also a question from the working group. So this is for Austin. And part of this is a comment. So the value of Indigenous and traditional knowledge needs to be elevated. This knowledge is real life and not an educated guess. And so what can we do to accomplish this? And then you are in a particularly significant role for your region and for Alaska, I would say. And so with this, expanding on that, what steps do we need, like on the part of Congress or the federal government, to equitably include Indigenous knowledge in the processes, in their processes?
Well, if you would have asked me 5 years ago if the Bering Strait would be ice-free in February, I would have said no way. For the last 2 years, it's been totally ice-free. In February, in the deepest part of winter, it's been ice-free. For that question, I think I'll concentrate on Congress. And there's a quote from Bertrand Russell. I might not get this right, but it's a healthy thing, he says, to hang a question mark on those things that we've taken for granted. A very eloquent way of just saying, question authority, question power, question what you know, right? In Congress, what I've seen over the last several years, if you've paid attention to U.S. Senate committee hearings or U.S. House committee hearings, there are two things that I've been very frustrated with. And that is, number one, this sort of a fallacy or false dilemma that congressmen get into when they're discussing the Arctic, when they're discussing climate change. Questions during those committee meetings are often couched in a yes-no form. Answer the question on climate change in a yes-no fashion. Answer the question on shipping in military strategy in a yes-no format. Even if it might seem like the obvious question is yes or no, I don't think that that's the case. We don't live in a binary world. There are more complexities to the questions that are happening in the Arctic, the things that are happening in the Arctic. The other thing that I'll mention on that is the rhetoric that is indicated with our politicians, and that is national interests in the Arctic, exercising national interest in the Arctic. And for that, I'll give a really small history lesson, history reference, we'll say. In the late 1800s, the U.S. Revenue Cutter Service, which is the precursor to the Coast Guard, commissioned a couple folks, Captain Healy and Captain Merriman, into Alaska. And in the late 1800s, Captain Healy and Captain Merriman bombed the native village of Angoon, destroyed the village of Angoon for what I consider a rather unfortunate miscommunication. Some years later, Captain Healy was dispatched to the northern Alaska to ensure the national interests in the Arctic region. When Healy came to my ancestors' hometown, Wales, and I'm going to plug another reference here, the book The Ice Windows, if you haven't read, which is a series of letters from teachers at that time from Wales to their family in the south. When Healy came to my region of Alaska, the native people there, my ancestors, replaced their faith in God with the fear of Captain Healy and his guns. When the U.S. Coast Guard cutter Healy visits our region every year, which it does a couple times a year, for me it's a very unpleasant reminder of how the U.S. is exercising its national interest in the Arctic. Now, we are not being directly threatened anymore, but we as Native people, we are replacing certain things about our traditional way of life with other things. And in this day and age of national interests, whether they are military, corporate, industry, development, science and research, for us, it generally means destruction. Destruction of long-standing traditions, destruction of longstanding history, and destruction of longstanding places. So I would like the steps to be that Congress engage in a little bit of questioning of themselves, questioning if things are right, questioning if this path is the correct one, and not engaging in a very bipartisan political discussion.
You're not off the hook yet. So. I've got a second part of that. And part of that is we have a mixed group here with our own people here. So to that end, what steps do we need on the part of Indigenous knowledge holders to equitably include Indigenous knowledge at those tables? So what's our responsibility? And so we've seen some of it demonstrated here, but can you expand on that?
Well, I think our responsibility is to demand resilience and adaptation on our own terms. We often hear in political discussions this idea that we are resilient, we are adaptable, but I think that what we need to do is demand resilience and adaptation on our own terms. A very good example of how that is, well, not taking place, but a good example of how we are really trying is with the BLM Resource Management Plan, the Bering Sea Western Interior Resource Management Plan that is now under consideration, a long multi-year process that began with scoping in 2015, 2016 for a period of a couple of years. And then this last year and a half, the unveiling of a very dramatic change in how Bering Sea Western Interior lands are going to be managed for the next 20 years. And during scoping, people in communities said very clear things about how their land should be managed, that they shouldn't be mined, that there should be areas of critical environmental concern considered. But what happened in the BLM process was that scoping did not reflect the plan, right? So had some sort of process been in place in the beginning that better captured scoping, had there been a process in place for tribes to have really expansive capacity, really powerful capacity to make change during scoping or during other resource management plans or during other federal actions, right? There may have been an opportunity to implement an idea from our region. The problem that we face in rural Alaska, and for folks like myself, is that we generate lots of ideas. We know what's right for us. We know what's right for us. Our many, many thousands of years of living where we have generates wisdom. Wisdom. We know what's right. So there has to be a way of implementing that. And it has to be primarily not what we do, because as Maya said earlier, we're doing it. Our voice is on the table. The other side's not listening.
So part of what I hear today is the collective responsibility that we have. We are showing up, and then how are we being responded to, and then pushing those spaces. Listening to your comment there, or your story there about the Healy. Yesterday I heard another story by somebody here based in DC that talked about being on the Healy this recently, and they were going through our waters there in Alaska, and I asked, well, did you have an Indigenous voice on the ship? No Indigenous voice, right? So that's a clear example of a great opportunity for scientists to be on that, for other folks to be on that, but the opportunity missed for not having our voice on that. And then what's the structure that needs to be in place? Because clearly you saw that type of knowledge that's held here, and you can see in these photos that could be expanded upon in that kind of space. And so I think thinking about those things and hearing the comments that were shared here today about how do you expand that space and what is reciprocity. I am fortunate enough to also have been involved in some of the regulatory process through another hat that I wear. And I think that's a process that is a very challenging process for our folks, but it's also a place that science is being used. And so when we're thinking about the reciprocity of our relationship in terms of both opening up our communities and working with the science community and working with policy, then at the same time, there are concepts that can be shared with our community, like in understanding and expanding the concept of best available science. What does that mean? Because you see in these three people represented here that we are not only having to learn and understand the governance processes that are in place, that are not our own traditional government processes, but we have to show up and we have to also use the data to advocate. So we run the gamut. We're not just dealing with scientists, we're having to advocate and push the dial on things. And so understanding like what is the best available science that goes into some of these documents and what that concept means for our people, so that when we run into these regulatory process that doesn't have the most current science, which many of the EISs currently don't have, the most recent science, that we know we can question that. Oh, we can question this science. So I just wanted to expand on those two because those two are examples that recently came out of some of these discussions. So are we about out of time? Okay.
Yeah, it looks like it, but before we hand the mic back over and we're pulled off the stage, we would like to invite all the Indigenous participants to join us for lunch today so that we can build on these conversations and see where we need to go from here. And we're going to meet in the members room. So please join us for lunch there. And we just wanted to thank all the panelists. Thank you very much, Goyana, Jaknak, for coming.
Everybody, is this on? Yeah. Okay, we wanna continue. We're gonna try to catch up a little bit of time, but we'll make sure that for the poster presenters afterwards, there's still an hour and a half for lunch. So I'll give that depending on when we end here. Our next panel is going to do a deeper dive into some of the marine ecosystem changes, some of which we already heard about. And obviously, it's a change. We've already heard a lot about how rapidly things are changing. So we're going from an ice-covered ocean into some that's much more accessible to commercial activities, and with it, increased vulnerabilities and variability. So we want to talk about the social and ecological implications that come from the changes of the marine ecosystem. And here to do that, we have three wonderful people from across the Arctic representing three different places and points of view. And I'd like to introduce now, we have Line Kielsen-Holm from the Greenland Climate Research Center. I'd like to come stage. Thank you. We have Anne Robertson from U.S. Senator Lisa Murkowski's office. And we have Paul Wassman from the Arctic University of Norway. Thank you. So Paul, I'd like to start with you. We've heard some of these changes. I wonder if you can speak specifically about the changes in the marine ecosystem. What are some of the major things we've seen, and why does it matter that we understand these?
Well, as you mentioned, there has been a lot of changes in the Arctic, in every part of the Arctic. And in the area where I work, of course, the greatest changes are the reduction in ice and arrival of new boreal species, changes in fisheries and fishery patterns, and last not least, changes in productivity. The productivity in traditional fishing areas is decreasing while it's increasing in the north. And all that has, of course, implications for the main interest in the Arctic in Norway, which is based on fisheries. If all the fish from the Barents Sea, fished by Norwegian fishermen, would go to the United States, that would be 17 fish meals per capita per year. That tells you that it is an important thing for the national economy, and it has, of course, also important ramifications for the culture and the economy at the coast, and then both Sami and Norwegian. So we pay attention to the changes, and the changes have immediately implications for how life is taking place now and towards 2050.
Thank you, Paul. So from a scientific perspective, we have made these investigations. We often study the open ocean and systems into the deep waters and try to understand these connections through those studies. Line, from a community perspective and from Greenland and other Arctic residents' perspective, where we have this strong bond to the marine environment and dependency on the marine environment, what are some of the major changes that you have experienced, that people have experienced, and what are the implications of some of those changes?
In Greenland, where I am from, we have been working with these issues, talking with people, the users of the resources in our areas for more than 15 years. Going from place to talk with people about the changes that they have observed throughout their lifetimes. And there are changes both in the ocean, both with the animals, both with the seasons, the weather, but these are environmental changes that they are talking about, but at the same time, our people are talking about other changes that will also have an impact on their livelihoods, like the global opinion on how we use the resources in our areas that have had a lot of negative impact on our livelihoods, like the seal banning policy. That's just an example, which impacted a lot of families in Greenland. But these global opinions towards our livelihoods has also risen the awareness that the Greenlandic people, the Inuit, we are not isolated in our regions. We are part of the global community. And of course, we want to learn from others, but we also offer to help to gain some more knowledge by working together.
So Anne, maybe over to you. So, we hear about these changes, and you can hear some of the implications, both from a kind of system science perspective and its importance because of all the interdependencies and then the implications to people. And of course, these changes are increasing ever rapidly. So from a policy perspective, how do we deal with those? Like, do we have the tools that we need, both in terms of the frameworks to address the issues and also at the pace that we may need to address them?
I'm going to answer your question kind of in reverse and talk first about some of the lessons we're learning, I think, as policymakers, as we see all these changes happening rapidly and getting faster and faster. The first thing that comes to mind for me, as someone who works on marine policy, oceans, fisheries, for a lawmaker who has a hand in shaping budgets, looking at how the federal government operates in our nation's marine spaces, is how well are our systems keeping up with the pace of change in the Arctic? And the truth is that they, in many ways, are not. So we see that, Congress is not known for doing things quickly. I think we can all agree on that. But we see funding needs for science that we're scrambling to address. And the changes are happening so rapidly in places like the Northern Bering Sea that we may not be able to keep pace with what the science needs are. And it's difficult because the Arctic kind of touches every part of the federal government in different ways. The way our government is set up, it's split into agencies that have their own kind of topical focus. And as a result, what I think the tools we need to put in place that we kind of have but could be doing a better job of using are making sure that there's really strong coordination and discussion happening across the federal government from all agencies that are operating or affecting some way issues that are relevant in the Arctic as we see rapid change there. So some of those convening spaces already exist. The U.S. Arctic Research Commission is one that kind of sets the science policy goals for the United States, and then the Interagency Arctic Research and Policy Committee, housed over at NSF, kind of works on implementation, making sure those priorities are translating to the ground. But at a higher level on federal policy as it applies to strategic interests, the security of communities in the Arctic, the security of communities outside the Arctic that are maybe affected by the Arctic, that coordination, I think, can be strengthened. And that's an effort that I've been focused on in my work as a policy staffer on Capitol Hill. So.
Thank you. And so while I maybe get a tablet so I can see the questions from the audience, let's follow up on some of the points that were discussed both earlier today and yesterday, and some of you mentioned them. So it has to do with collaboration and cooperation, right? And we hear about these at all different levels, right? There's challenges within or needs within the different departments, say within different governments, right? Or certainly and across governments, if we think about that. There are different ways that communities collaborate, both within a nation or geography, and try to do this on a broader scale. And there's lots of really positive initiatives as well amongst scientists and figuring out, hey, we need to collaborate across disciplines as well. Okay, so those exist, and we have examples for those. I was wondering maybe through each of you, through your three different lenses that you think about, do you have good examples where either between the groups you represent, two or maybe all three of them, there has been good ways forward, and say we have worked together with this other group really well to help, for example, decision making. We have worked really well with the community to address this problem more holistically. So I'd like this point of view from all three of you, if you have a good example. And if you do, would you be able to extract some nuggets out of those? Like what made that actually work so that we can, and it doesn't matter where this was, can we have what we learn from those that we can apply perhaps to other places? So maybe I'll start with you, Lynn.
Yeah, yesterday we were, somebody was saying that we have more questions than answers in regards to the Arctic region in connection with what science is contributing to the understanding of what is happening in the Arctic. But I think that working together, all of us, hopefully will pose the right questions, more questions that are of importance also to the Arctic people, which has not been the case for many years. One work we did and is called Sigo Inuitida, which means the sea ice, the people, and the weather, the universe. And from that work, which was interdisciplinary but also transdisciplinary in its how we worked together, it was international. We had hunters and fishermen from both Alaska, Canada, and Greenland, and researchers like myself, anthropologists, but also physical scientists working together to understand the life in connection with sea ice, the changing sea ice. And I think that was a very good way of working together. We even retranslated a book we did, The Meaning of Ice, into the 3 different dialects, Inuktitut, Inupiatut, and Karatsut, because we want to, what we learned from this to be understood also at home, that this is not only for the information of outsiders, but within our own communities.
And yeah.
I think that, excuse me, we see collaboration within government, but also outside of it. I think in Alaska there are some really excellent examples of Indigenous knowledge, local communities on the ground in rural parts of the Arctic on the coastlines, working closely with scientists to provide the information that's needed to inform the people back here in DC about what's going on. Those examples, I think, have been limited. There's more that needs to happen to really entrench that and make sure that those conversations are happening consistently. So developing stronger channels between communities and policymakers here in Washington, D.C., who are either setting research priorities or, once science has been gathered, information has been gathered, using that to make a decision. I think something that we're focused on in Senator Murkowski's office, and she's introduced legislation to this effect, is how can we institutionalize, the same way I was talking about some of the collaborative spaces within government, but how do we build ways for those conversations to happen outside of just the federal government and with the communities on the ground that are being affected by Arctic change? So Senator Murkowski's introduced a bill called the Arctic Policy Act. It would update the Arctic Research and Policy Act, which originally set up the U.S. Arctic Research Commission, for example. And what that bill would do is it would make permanent in statute the Arctic Executive Steering Committee, this group of the deputy level agency, high level leadership, to make sure those conversations are happening across government. But it would also set up, starting off, a Bering Sea Tribal Advisory Group, a group of tribally elected officials from the Bering Sea region, Bering Straits region, to convene and cooperate with the Arctic Executive Steering Committee to make sure that information, that dialogue is taking place and that those relationships are being developed. I think, I'll try to be mindful of the time here, I think back to the word cloud that I think David put up on the screen earlier about how, and he was talking specifically about adaptation, but efforts can be very diffuse across the federal government, and for policymakers who have an oversight role and a funding role, like we do in Congress, I think we're trying to think creatively about building systems that really allow for the information exchange and the collaboration that needs to take place. So that was kind of a long-winded answer, but.
Oh, thank you. Thank you for that. Paul, for you, I'd like to combine that question I just posed with a question that came from the audience. So there is lots of great examples about scientific collaboration, right? We've heard about, and you know, so in the Pacific side of the Arctic, there's the Distributed Biological Observatory, for example. There's the Pacific Arctic Group. There's lots of national, international collaborations that have been very successful. And you have been very instrumental with the Nansen Legacy Project, which brings also in kind of policy and has been we went beyond just the scientists, right? So can you speak about that example or perhaps other examples? And then given the scope of the changes and the kind of the need for the system understanding, there's a question here that relates to this and is wondering whether you think that marine scientists need to be educated in a somewhat different way to be able to respond to these changes which are different from the ones we've seen in the past.
There's a lot of things I should take in one go.
No pressure.
To start with the last point, I think there's a lot of people which should have a different type of education. It's not only facing the scientists, but with regard to the type of Arctic which I'm facing in the Eurasian sector of the Arctic, where fisheries are an important thing, I think there's a good cooperation understanding between science and management. And that is reflected in the way concessions to fish or permissions to fish are given, and that is reflected in the good cooperation, bilateral cooperation Norway has with Russia. And I think the sustainability or the level of fishing on fish stocks, on marine mammals, etc., they talk for themselves, that there is a good management regime. And it's based on the understanding that we are dealing with ecosystems, so we need a systemic approach, and that all the systemic data are on the table when, for example, in the Nansen Legacy, decisions have to be made in the hitherto ice-covered areas, which will get accessible for economic activities in the future. Because the Norwegian Parliament or the public could demand for a sustainability report before a permission is given. And for that, you need that type of... and I think in Norway we have been quite successful to do basic science, which then immediately serves the need for the politician and managers to do their job. And then you have to remind me on some of the points I should also ask.
No, that's okay. I think you addressed some of the main issues about collaboration, in this case between the policy and the scientists working together on these larger scales. Yeah.
But there's one point I would like to make. When it comes to cooperation, we need far more international cooperation across the Arctic, because we have all our understanding from where in the Arctic we are, but the Arctic is a circular system. It's a Mediterranean type ocean, and Mediterra means in the middle of the Earth. So there's a lot of Earth around the Arctic Ocean. And the scientists, in principle, are ready to go to make to develop a pan-Arctic view, so that we can look at the Arctic as one through the various eyes which have on that is something which is lacking, and that creates difficulties also to understand our own house garden. So Pan-Arctic integration and circumpolar cooperation, at least on the scientific level, which should be easy to go because there is not so much politics involved or UNCLOS or this type of things. So that is something I would really like to see in the future.
Well, let's talk a lot, but there's some more, and there's a couple of questions that are sort of go around this issue of this more holistic view. So we've heard a lot from the Arctic residents and through the Inuit Circumpolar Council. There is already a big effort to kind of think about, and naturally think about this on a broader scale and not think about the geopolitical modern divisions that we have. From a scientific perspective, there's the funding streams and how it goes there, and scientists are good and creative of how to kind of figure out and working together across some of those boundaries as well. And then so there's good positive things towards that. From a policy intergovernmental perspective, we use the ministerial, the Arctic Council, and a few other vehicles like that. So your point, Paul, was that there's more there, and we have this information. From a coastal residents perspective, you are trying to bridge those gaps as well and bring those together. So how can both of those things merge with the policy needs and creating that collaboration on another level when it comes to, yes, this is one system. We understand, people have understood this for a long, long time. Scientists are trying to create this conceptual model of a combined Arctic. How do we bring those together? And then how do we bring those together if we're going to have to create policies or govern in one way when we know these systems are interconnected? So it's an open-ended question, but be curious to hear your thoughts from your different points of view. Paul is making the point from more is needed there. So what would that be? Maybe that's to all of you.
I think a place that we can start is simply by sitting down and thinking strategically about where can we make progress on collaboration and science. There's a strong history of collaboration across Arctic nations and non-Arctic nations to further our understanding of the Arctic Ocean and that kind of larger polar system. But outside of just the scientific work, I think that we can be doing more as policymakers to sit down and scratch our heads and say, well, what lessons could we be sharing across national boundaries, across, over the poles? What lessons can we be learning about? I hear so much emphasis put on developing a blue economy in the United States these days, developing sustainably managed fisheries, building strong coastal livelihoods, and that is work that's very much been progressing for many years in places like Iceland and Norway. So are there lessons that we can be talking about and learning together on topics that aren't strung up in those political kind of obstacles? I think that topics like strengthening collaboration with communities, we can probably learn a lot from each other, and also starting to talk about resilience and how we adapt. I think that the more knowledge that we put towards those discussions, from not just here in the United States but elsewhere, the better.
Maybe we should start thinking about shifting the paradigms that are putting the way we are doing science today, putting the framework for how we do science. But at the same time, it can't be done within the science itself, because the funding agencies and those who are funding science, they are also putting some frames that the scientists should work within. And maybe a future conference could try to solve this thing to bring different ways of knowing closer together to get some more, better results that are benefiting not only the scientific community but also the people of the Arctic, but also at global level.
Thank you. I know Brendan is taking notes. That'll be the next conference he's going to organize. There's a question here. It relates to a comment that was made earlier, very powerfully so, in the last panel about youth and the role of youth. So this is a question to you, Anne, about what's your point of view or your vision for having youth become policymakers, or is that something you would recommend, perhaps? Or how do you see do you see a way for closer involvement for youth in that process?
Absolutely. I think that there are not enough Alaskans, not enough Indigenous Alaskans working in Washington, D.C., working on policy kind of close to the source here, where all the discussions take place, where we hear it as members of Alaska's congressional delegation, of the frustration about, a lot of the discussions that take place in DC affect us back in Alaska, and that's a challenge that needs to be overcome. But I do think that there are incredible opportunities, going back to kind of how science is happening in the Arctic and in Arctic communities, participatory science, science that is being led by communities to address issues that are relevant, and with support from agencies who are able to put resources towards that. That I see as a really incredible opportunity for young people to get involved. And there are like weird barriers sometimes in the federal government about hiring interns and who can work where, and it gets down to a very detailed level. But if we can focus on looking for those obstacles and finding ways to get young people involved, especially Indigenous young people from Arctic communities that are experiencing change, that I think will ultimately create a strong pipeline to get scientists from Alaska, Indigenous scientists, policymakers, to start building a greater presence here in Washington, because I'm always so happy to hear when a new person from Alaska comes to town to work here, but there needs to be more of that. So any opportunity for us as policymakers to make it easier for young people to get involved in research that's happening in a community, to get involved in policy discussions that are taking place in communities or back here in DC, I think I welcome those opportunities and would love to keep focusing on that.
Great, thank you. Yeah, so we have actually a whole bunch of ambassadors from students on the ice here, and so perhaps we'll have students on the Hill, initiative or something.
We had a chance to meet with them.
We often hear about when policy decisions have to be made or need to be made about using the best available science. And as scientists, we're often really worried, and we heard about this already in past conversations about, we can say a lot of things. We have a lot of knowledge about these systems, but like everything else, we can't give you 100%. It's just not possible. So we provide information in ranges and other things, right? So the questions relate sort of to that and says, we are seeing disasters and hazards on the ground which are affecting lives. And why is the concern with best available science in order to make policy when we see the trends in action? And relates to we'll see later on today, the tabletop exercise of perhaps how that information kind of flows in. But if people are seeing these strong changes and they're affecting people's livelihoods in communities, why is the default, I think I'm interpreting the question here, why is the default going back to, we can't do this unless we have the best available science to make the decision? How do we deal with this dichotomy? Because we want to we need to respond if it's an emergency, and we want to respond immediately, and we want to respond in a more systemic way if it's a problem that may last, and we may need more information for that. But if people on the land are seeing those, how do we marry those two together, both from a integrating the scientific knowledge and indigenous knowledge as well as from a policy reaction point of view?
I think that the doubt, which is a core in science, you have to doubt your results in order to make progress. That core is very greatly misused in politics. And that makes that we come into, so to say, in dire straits. We have to keep to the core of the science, the doubt. It has to be better. Is it true like that? And then the decision maker said, oh, we need more, maybe it's not right, and we need more research. But obvious things which we can have some doubt on are good enough to make decisions here and now. And I feel very often unhappy about that.
And from your perspective, what do you think?
I think it's a tricky question for sure, and I recognize exactly what Paul's saying about how doubt can be used to delay or promote skepticism, obviously. I do think that it's the way government is set up, the kind of systemic processes that we use to develop policy, iterate policy, figure out, what the appropriate solution is, evaluate alternatives. For policymakers, I think that there isn't always really an understanding of what uncertainty means in a scientific context, that it's something that can be quantified in a statistical analysis, a coefficient of variation, whatever. I think that message isn't always translating over to the people who are just sitting scratching their heads at a proposal saying, well, if we do this, this could happen. It's likely that it won't to this degree, but that doesn't always make sense to people who have law degrees or public policy degrees. So I think what that speaks to is the need for policymakers to talk to scientists more, which is exactly what this convening is meant to do, simply so that certainty or uncertainty can be contextualized a bit, and perhaps put in perspective in a way that policymakers can understand. What does it truly mean when there is not a 100% positive answer, negative answer? This came up in the last panel.
But what about the flip side of that? So if from a scientific perspective, we haven't had a chance to study this well enough perhaps, or perhaps it's an issue that hasn't been addressed at all, or we can't tell for certain, it's like, well, I don't know if this is going to happen again next year. But the people on the ground are telling us, well, we're seeing this change. Like, scientists haven't been here because they're not everywhere. Can we do something anyway? So how do you deal with that? So you only have, perhaps you would like to have both the local knowledge or the regional knowledge as well as the scientific knowledge to integrate. But when you only have, and there's good examples of when you only have the scientific knowledge, right? Because that's we're kind of used to have that information pipeline. What if we only have this other side? How do we deal with that then? Is that sufficient? I guess that's really the question. How can we make that as valuable so that there's this pipeline that's open from that type of information just as it is perhaps from the scientific side?
I think it's sufficient to get the ball rolling for policymakers to at least start, looking at solutions and talking about those. And the challenge of, like I spoke to at the beginning of the panel, of obstacles in government that preclude kind of that response and that adaptive capacity to react to the risks and new challenges as they arise. A case in point that I think of is the changes that we're seeing in the Northern Bering Sea. The cold pool has diminished or practically gone away for 2 years now, I think, and we are struggling to get sufficient money to NOAA so that they can do the science in the Northern Bering Sea to understand where fish are going, what the changes are happening. And it's incredibly frustrating to be to be pointing that out and then running up against challenges in the funding process. So I think that the information that we're getting from communities on the ground, Indigenous subsistence users who are identifying changes, that absolutely can kick off the process here of figuring out clearly what the problem is, what the drivers are, and what possible solutions are. But I think that we also need to be resourcing federal scientists as well to then go and work with those communities to learn more. I don't think that we can ever have too much information, but I do see how that creates, like Paul noted, the risk of people saying, well, we don't have enough information yet. So yeah, it puts policymakers and I think the people feeling the changes on the ground in a tough position, but I think that with more communication and more of that kind of collaborative work, we can at least start the process of policymaking to address that.
Lina, I imagine you have an opinion on this matter.
Of course, I think it's about time that we skip the skepticism towards the Indigenous people's knowledge, and because to my understanding and the way I see our knowledge that has been gained for many, many years, for millennia from the area, we need to have more, to be more open to other ways of knowing, because because the people who are living there, they are observing their environment year round, while to our experience, a lot of scientists are only coming for a very limited time of the year, and they will have to gather all that information through many years to analyze them, and afterwards they will have a result, hopefully. But the people who are living there, if we give them more trust or trust them more, that will be to the benefit to not only to the people who are living there, but also to the rest of the world.
Yeah, thank you. There's a series of, I mean, there's lots of great, fantastic questions. There's a couple questions that relate to capacity building. And so we hear often about where there's an institutional capacity that's needed. And I know somebody said yesterday, I don't want more government agencies or institutions. But at the same time, I know, Lina, you have spoken about ways that information could come together, and we heard it yesterday. Gunn-Britt talked about as well about Indigenous organizations that may exist or we may expand on. So there's enough capacity to actually do all this. We're talking a lot about communication. Everybody should be talking to each other. Information needs to be treated respectfully. Do we have enough capacity at that level? What may that look like? And then on the from the both scientific and Indigenous community perspective, but also from a management and policy perspective, do we have actually have the capacity to adapt and respond in the right way? Right, and so, and then I'll get back to that. I'll let you think on that, Anne. I'll get back to this because I'd like to spend a little bit of time that we have left on that. So let's talk a little bit about capacity building and the need for that. And I think there's been a lot of really positive trends towards that, but I'm not sure it has addressed quite all the needs that we have. Would you like to have Lina?
I think capacity building should go both ways, or multiple ways, because that will be the most respectful way of doing it. We have to teach our children about the outside world of our community, but we have also to teach the outside community about our world. And only in this way, the communication between different ways of understanding our being in the universe will bring us closer together. We can't do that by always having these very different ways of understanding ourselves separately. We have to try to bring different ways of knowing together by communicating these entities. But communication is not always easy, especially with indigenous peoples that have their own languages, many of us. In Greenland, we have Karalsut, and then Danish, and then English is coming afterwards. So the information, we can't extract that directly from the internet, for instance, or from journals. We need help to get to be able to learn from it. So, yeah.
Paul?
In addition to the valuable point Lene is doing, there's also a lot of capacity which is not used in our nations, because ministers and institutes and very much capacity is enshrined in formalized structures which are not often used to the very best for the nation. So on the structural level, how to combine institutions so to answer the grand question which a nation has, a lot of formal things could be done to improve that.
Okay, so and I want to make a short plug, and I'd like to get to the adaptive management question here towards the end. But we've heard a lot about communication and the need for communication, and often there's like, oh, we could do more communicated, we could better. As somebody who spent a lot of time doing science communication, I will say that there's a lot of excellent scientists. They're in this room, many of them are in this room, which are fantastic communicators. And they actually spend a lot of time going to communities when they're coming in an outreach. So I'm sure more could be done, but just say there's lots of wonderful examples, and those should be acknowledged at the same time. Okay, so very, very quickly, Anne, the question of adaptive management is not what we hear about, and it's often the solution to these quickly evolving issues and problems that we have, because it needs to be less static. There are mechanisms, for example, in fishery, through the Fishery Management Council, we were at ICES yesterday, where there's these cycles of how information gets integrated and then adapted from year to year, or from maybe every 6 years or so. So there are, however, and it's been good in new ways of thinking, that adaptive system needs to be much broader, but it needs to have adaptive policies. It needs to have a lot of more adaptive things. So is that a reality, really? Is this a theoretical construct that we like, or in the reality of policy, do you think that creating more adaptive mechanisms is possible? What might they look like, if it is possible?
I think the biggest change or progress that could be made to improve adaptive management capacity at the very beginning of the process of resource management would just be looking closely at how we fund science and how we fund science. I go back to the example of the Bering Sea, Northern Bering Sea, and how we're struggling to get survey funding up there while it's like one of the most changing marine ecosystems in the world, probably. So figuring out how we can build flexibility into these just like very basic systems of like getting money to an agency, or transmitting priorities from leadership at an agency that conducts science down through to the scientists. But I also think that what keeps coming back to my mind is that to build that adaptive capacity in high levels of government here in Washington, D.C., it really requires more education and communication about the importance of the Arctic, the importance of addressing the changes that we're seeing up there. And that is a battle that I think we're certainly fighting every day in the Alaska delegation of explaining to high-level officials why the Arctic is important. And that's something that I know many of you here are involved in, or I hope you become involved in, is talking to people who have kind of a nexus to the Arctic, but maybe aren't as aware of its importance as they could be. So I'll conclude on saying, we all know that what happens in the Arctic does not stay in the Arctic, but what happens in the Arctic also shouldn't stay in the Arctic. It needs to be communicated out to Washington, D.C., to every high-level cabinet secretary. I mean, any opportunity there is to expand and inform more decision makers about why this region is important, I think we need to take those opportunities, and that's how we can really build the capacity to be flexible.
Thank you, and I imagine the same applies to many other governments as well, not just the U.S. government, right, where those are needed. So unfortunately, we're out of time. It's a good point to end on about that these communications need to continue. There's lots of other really excellent questions that you've had, and please find the panel members and continue the discussion. It's all about starting the conversations and continue discussions. So I'm going to make a few points about lunch before I let you go. But please help me thank the panels for their insights. Thank you so much. Okay, lunch is upon us. Oh, there's a secret note. Okay, so before I let you go, the Indigenous Participant Working Group is meeting in the boardroom, which is not the members' room. So if you walk back towards the main entrance and go to the southeast corner, for all Indigenous participants. So please there, that's from Rochelle. Thank you. The format for the posters and the lunch is like yesterday. You all, by the way, did a fantastic job yesterday about sticking to your groups. Thank you so much. It was great. There wasn't really any bottlenecks anywhere. So if you can sort of remember kind of what group you're in, please let the poster people from today, new set of poster presenters, let them have their lunch first. There's only presenters in 2 rooms today, so if you can kind of let them have lunch, and then we can sort of spread out. We probably don't need to micromanage this today. However, I want to make one extra plug. Yesterday, we all got very excited because Brendan said, go have a drink and have fun, and we all did. But then very few people actually went to the posters in the evening. The posters are also fun, okay? They're part of the fun, all right? So please go there. So this evening when we break, and we'll try to remember this, but the poster presenters put a lot of work into their posters, and this is kind of the sessions that they have. So please grab your drink this evening and then go back to the poster sessions and have conversations there as well. Thank you.
2, 1, 2. Can you guys do an audio check with? 1, 1, 2. 2, 3, 4. 1, 2. 2. 2. 2.
Russian nuclear icebreakers have accumulator systems?
I think so. I think so, but I'm not, 100% sure.
What's the question? Able to gather, submarines don't.
Yeah, because of space.
Space.
Do they have what?
Accumulators.
I think so.
You know, the signature safety system in terrestrial LWRs is a response to a large break, which they have to shove a lot of water.
Good to see you. How you doing?
Good. And it's one of the most costly components. Is the ECC.
We have met a long time ago. Amy Kennedy with Noah.
I haven't met you.
Yeah, it's too bad you can't talk to the
one
guys
of Noah's
at the
folks.
shipyard.
People quiet down on some of this.
It's Barrett.
Well, Mildred Moore, that's for sure.
Yeah, I don't know.
And they have
No,
Forward
she's
appearances,
here
they look to be a
in
very
DC.
robust design.
She's coming up. She's on
They've been very
I've been on Russian
International
submarines.
Climate
I've seen some Russian submarines,
IPCC.
but I've just seen a
And
Victor
there's a new
3, and I
report
mean,
coming
it's got a containment vessel.
about
It's a
impacts
very
of climate
robust
change in
design,
communities, and
but
she wanted to get out and visit some
they
communities
play a lot of
before that
games
report
with the
comes
fuels.
out. So she's coming up. I think she's going to.
I don't know anything about their icebreakers.
She's talked to Kuwait. I know that. So
I just know.
not apparently you.
You don't want a lot of local drinks around.
My name's Randy.
Hello, Randy.
I don't know if you remember, I think this would have been probably 2016. I did like a several-month detail as a deputy at OAR. Actually, it's what the job Gary Matlock has now permanently.
Yeah, okay.
So that's right, and COVID
vaguely.
just come in.
Oh, yeah.
So.
Well, she's been great to have there. They need
sublimation. It sublimates and atomizes, so it never hits the ground.
She told me she had a concern at one point with all this IPCC work and all the work you need to do at home.
Just a light mist.
I mean, it's always going to be a challenge. But
well, she's kept it up.
That's good.
And I don't know if you heard, but she's going up to Alaska on her first trip. Still, as part of IPCC, they're getting ready to release another report talking about impacted communities. And she wanted to get into Alaska and get out to some communities and, get some
Right here?
From the Navy or something.
Oh, I see. Oh, yeah.
Goes next week for that. So.
Good. Thank you. You guys are doing all the heavy lifting.
Lieutenant Colonel? He's a lieutenant colonel.
Yeah.
Late.
Did you get? We appreciate it. So Francis didn't mean it when he said have fun. He just meant have a little bit of fun. He didn't mean have this much fun. So, and as you can see, we've abandoned the small panel format. We've decided against This is different, obviously, and I'll let Sherry Goodman and Jim Townsend tell you more about this, but this next hour and a half comes out of a challenge that really came from our partners at the Wilson Center when we were putting this meeting together, and they said, well, don't just have the scientists talk to the policymakers, right? Let's have the conversation go both directions. And I turned it around and said, great, help us put together a session that would have policymakers tell us something about what we as Indigenous knowledge holders and scientists need to know. And what came out of this is this demonstration. This is only a demonstration of a method that's used in decision making that a lot of us, at least in the science world, aren't that familiar with. So without any further ado, I'm going to turn this over to Sherry Goodman with the Wilson Center, and you can introduce Jim and everybody else. How's that?
Okay, thanks, Brendan, and thank you all for being here. We're going to try to keep you awake after the lunch hour and entertained and engaged. I'm Sherry Goodman. I am at the Woodrow Wilson International Center Polar Institute. Actually, like many of you, I have multiple hats. I'm at the Wilson Center. I'm also at our partner, the Council on Strategic Risk, which is the home for the Center for Climate and Security, which is one of the co-sponsors today, and our other partner is Sandia National Laboratories. Jim Townsend and I are here in our capacity with the Wilson Center and the Center for Climate Security, as well as my partner, Peter Davies, formerly of Sandia and now the Woodrow Wilson Center. I want to thank all of our partners. I want a special nod to Lori Parrott of Sandia. Thank you. And to our great Wilson team that's helped put this together, Marisol and Clara here in the front row. But if you have any questions or any problems, it's all my fault. Because I have 3 kids, so like, you know, I'm the mother of climate security, I'm the mother of my 3 kids, and I did hear Denali and the others of you this morning that we want to bring the youth more into it. I'm willing to take off 25 years right now. Okay, but we're going to bring you in as part of the discussion because we're all of us, we are going to be very inclusive as much as we can. In the 90 minutes we have to do a demonstration of a scenario that posits a nuclear shipping incident in the Bering Strait, so we can look at a series of both how to respond type questions and what kind of research we should be planning now for a future scenario. So this is a way of bringing together in a format that would normally be done over at least most of a day, if not a couple of days, with actual role playing of people in different roles. We're not going to do the formal role playing, but we have a lot of players who have been actually in those roles, decision-making roles, in the Coast Guard, Navy, Air Force, operators, local first responders, scientists, indigenous scientists and operators, governance officials. So we've kind of covered the gamut with a great group of talent up here. I'm going to direct you to look at their bio so you can read more about their expertise. And what we'll do today is raise a number of issues, questions, problems that need to be addressed now and in the future associated with a potential nuclear shipping incident in the Bering Strait. So with that, I'm going to introduce my co-pilot here for this exercise. Jim Townsend and I have worked together in the Department of Defense since the 1990s at least, right? Maybe back even a little further. I served then as the Deputy Undersecretary of Defense for Environmental Security. Jim has most recently served as the Deputy Assistant Secretary of Defense for NATO and European Affairs, and so we've both worked in the region in a national security context, and we're pleased to be working here and engaging with all of you today. Over to you, Jim.
Thanks, Sherry, and hello, everyone. And I do know this is hard after lunch, but I think you'll find this interesting. And I guess I would start off just to say that we're kind of doing this for you. in the sense that if you, through the course of the next hour and a half, hear something that sparks your interest, or you see a problem that you think you can have a handle in correcting, that's great. That's the takeaway for this, is for you all to leave this room and say, I'm going to start working on that particular issue. Because the big goal of what we're doing today is to try to give tools and resources to our successors in 2050 in Alaska, or in the Coast Guard, or in other parts of the government or the indigenous community that might have to wrestle with the problem. So this isn't necessarily about a nuclear aspect or just maritime security. It's not a specific scenario issue problem. It's a bigger picture of what do we need to be doing today or tomorrow after this conference is over to prepare the tools, to do the research, the scientific research, to make sure that 50 years from now, whoever's going to handle a problem that might look like this, they've got resources then that they don't have today. And that's what we're trying to do. And we're going to tackle it through a couple of ways. The first one is this. This is a two-parter. The first part is going to be the actual scenario. The scenario has got two parts in and of itself. I've got part one. Sherry has part two. In part one, what we're going to do is lay out for our panel a situation that has happened in the Bering Strait, in the shipping lanes there. And I'm going to try to get at two aspects. The first aspect is, in Alaska, among the Alaskan government and the resources that decision makers have in Alaska, who should be talking to whom about this, and what does that chain look like just in Alaska? Because the second thing that I'm going to try to get at is, what's the connection between those folks in Alaska and the national and international authorities, whether it's the Homeland Security, whether it is the Department of Energy, whether it's Russia and China, because as you'll see, these two ships are not American. How does that work? How does the network work within Alaska, and then between Alaska and the other elements of the U.S.? And this also includes the indigenous community. How does that all work together? And so I'm going to sort that out, and then I'm going to turn it over to Sherry, and she's going to step the scenario up a bit. This is where we're going to have this maritime incident have a nuclear energy aspect to it. We're not talking about nuclear weapons. We're not talking about anything like that. But we're talking about an icebreaker that all happens to be nuclear powered, as the Russian icebreakers are. So she's going to handle then this aspect of that network that I described. Are they able to handle a problem that's been stepped up like this? So for the first 45 minutes, we're going to do this scenario, and we're going to hear from all of our experts on as they grapple with these problems. The second part of this event here on this agenda is the last 45 minutes, where we're going to drill down with all of you as well, part of this. We're going to drill down on what are those things that we need to be working on today or tomorrow. So we're going to, in a sense, we're going to harvest the discussion that we had in the first 45 minutes, so that we can really identify some areas of work, scientific, other aspects, policy making, communications, Alaskan government, indigenous community. What are some areas that we need to begin to work on? And then we're done. We go into a break. You get to have some coffee and recover from this. So without further ado, Sherry, I think I'm going to go ahead and start. So let's see, is this, there we go. So let me give you the background to what's happening in this scenario. They have all seen this, but you haven't. So I'm going to read it to you, and you'll kind of get the idea of what's happening here. By 2050, Russian oil and gas fields are producing large quantities of LNG that is shipped year-round along the northern sea route. In winter months, during the extended navigation season, ice-hardened LNG tankers are escorted by Russian nuclear-powered icebreakers. In late November 2050, an LNG tanker is transiting the northern sea route, escorted by a Russian nuclear-powered icebreaker. This tanker is Chinese-owned, but operated under a flag of convenience from another country. So you have something that you see every day, an icebreaker. and a commercial ship behind the icebreaker making the transit. The first move. A powerful winter cyclone hits these ships as they approach the Bering Straits region. And the LNG tanker astern the icebreaker collides with the icebreaker. The master of the LNG tanker sends out a call for help. That's all we know, is that there's been a collision. It's happened in a very remote area, and there's been a distress call, so that's all we know. So let's now figure out what happens. What's the network, particularly in Alaska, that comes into play to begin to address this? And I'm going to turn first to Church Key to talk about this, and then we'll move on from there. Church.
Thank you very much, Jim. I'll be very quickly because, frankly, this is the initial response framework for a distress call being going out to this would certainly go first to the United States Coast Guard District 17, headquartered in Juneau, Alaska, commanded current day by Rear Admiral Matt Bell. Distinguished colleague here to my right, Mr. Phil Thorne, the Arctic Planner for District 17, works directly for Admiral Bell. Essentially, you would see the Coast Guard response piece of the equation swing into action quickly because there's a distress call. The questions would come out is that, first of all, is the call go out? Is it actually received? Who receives it? Because you are in an area where, at least in current day, communications are not assured. So now we're going to make the assumption here that by 2050 that region has got better communication than it has today. So a distress call made is actually a distress call received. In this case here, then the District 17 folks would be on the horn with the vessel masters to try to just ascertain is that the state of distress that they're facing. Are they taking on water? Are they able to maintain some semblance of control over their vessels, or are they literally at the mercy of the weather patterns? So as initial query back to ascertain what are the problems that they're facing, what level of stress are they under, and then they'll generate the kind of response based on nearest vessels, whether it's a Good Samaritan or whether it's going to be a Coast Guard asset that would be nearby to respond. Over.
And thank you then. That's exactly what we would hope the Coast Guard would be able to do, and that the communications infrastructure is there, which is a question. But let me ask, who then in the Alaskan government, who in terms of first responders in Alaska would be getting a call as well? Because it sounds like right now it's in a U.S. Coast Guard circuit, hopefully talking to the Chinese master, but maybe not. But let me ask, who wants to tackle that? What's going to happen in terms of Alaska?
Sure, I'll speak to that. Church Key is correct. The Coast Guard, this incident would start, is right now at the beginning, it's first and foremost a search and rescue case for the Coast Guard. It may evolve into other things as the incident progresses, but it's a search and rescue case. And as was indicated, we would launch our ships and aircraft in order to do that, and we would also rely on partners that would be available to help us. And I think of the state of Alaska and for help on shore with the troopers. Also, we have a good standing relationship with the Department of Defense up in Anchorage with their Alaska RCC. And there are also Department of Defense aircraft that can also help us in that initial response. We have very long-standing and mature relationships with them, and we can reach to them to help us with that initial response to save lives at sea.
Other points on Alaska, and then we're going to jump into Alaska to more of a national network. So more on Alaska. What's going to be happening here? It's late at night. Most of the Alaskan officials are in bed asleep. There's a few watchstanders trying to handle this, but the Coast Guard is busy on this. The Coast Guard might be talking to DOD, but in the governor's office,
probably forgive me, and Jim. So as a starting point, there's going to be an initial flurry of calls that go out. So the watchstanders will be talking to fellow watchstanders. The District 17 is probably going to make an initial call to the Department of Military and Veterans Affairs. The emergency management section that works within essentially a commissioner to the governor will be their command center, but they're principally 3 miles inbound to shoreline. and of course the territorial spaces. But there will be a lot of calls essentially among the community first responders within the state, between other mariners, for example, the Marine Exchange will also at Juneau is information sharing protocols with the mariners across the Alaskan coastal waters. Again, that network would be energized with all the players that are the regularly on scene people will actually be on scene and trying to ascertain the problem, how severe it is, what the steps are that are required to be taken. Over.
There is also a regional response team, which has representatives from all of the federal agencies plus state agencies and others that would be be put in play by Coast Guard, and that then initiates conversations similar to what Church is talking about throughout the federal and state networks.
So in terms of dealing with DHS, in terms of dealing with DOE, which might come later, but in terms of dealing with a lot of the national authorities, there is an exercised network that is robust already in place between those first responders, whether it's Coast Guard, whether it's others, and the authorities in Washington, particularly DOD was mentioned that's something that is regularly exercised up in the high north in the Bering region. That's something that is not unknown to those agencies that need to work together up there.
This is your cue, Phil.
Yeah, for the DOD, that's true. What is potentially lacking and we're working on is the time of year. So we have moved from a spring-summer mindset to try things out to a winter, February, March timeframe to work things out, because until now the environment did not generate a sense that that was going to be the case. But being the fact that it is now 2050, given the presentations we've had up till this point, we'll have a lot more open water, if you will, so it would also have increased the transit. We'd be in contact at Northern Command, both from the watch standpoint. As soon as this occurred, there would be contingencies that would go into place to get people ready, get flexed up. People would be moving towards airports. In the event the Department of Homeland Security asked for additional help from the Department of Defense.
Well, let me ask you another quick question, and then we're going to move on to another, to my final question, and that is, in terms of infrastructure that is there now, or that might need to be put in place in the future, and in terms of speed, because as we've discussed in the past, we're talking about a huge geographic region and not a lot of resources that are up there right now. So I think what's been laid out is very reassuring in a lot of ways, that there is a network there, there's a network in communication, there's changes being made to make sure that it can operate in all weather. But when you look at the logistics and the geography and the speed at which you might need to respond to this maritime incident, are there some issues there that you think that are something that we've got to work on between?
There's no place to go, for us to be in response. So if there would be something to be looked at, is where would you put it in 2050 or now for 2050? How could you sustain it? Do you have to have somebody there to sustain it? Could it be in a warm status, cold status, and you would just go? Because today, if you need it, you take it, and when you get there, you take it out when you come back. So it's a big place. It takes a long time. It's very expensive to get there. A lot of the challenges exist over the tyranny of distance, and we have to take a look at those infrastructure things. There are very few sources of bringing in response teams to sustain them and to help once they're there.
Particularly if we're dealing with a mass casualty situation.
Whether it's the Coast Guard doing search and rescue, whether there's health issues, et cetera.
There's another aspect to consider left of that, and that's when we think about Arctic in this situation in the 2050 time zone. How much could automated information systems aboard ship that are right now currently a relatively discrete set of information protocols are sent out on an automated basis? What more could you put into those systems in the year 2050 that could help achieve a better domain awareness or incident awareness by the command and control agencies that have been charged and vested with really at first response. So could you have exactly, transmission of discrete information regarding water level within the ship, within the power plant of the ship? What are the other things that are not even envisioned now could be incorporated into AIS in a time zone which would make domain awareness or instant awareness more readily achieved?
Well, I think that point actually, and then I'm going to turn it over to Sherry, I think that point is critical, because when we talk about what you've all laid out in terms of the network, it's something that is exercised, and I think we're going to see more done in bad Arctic conditions like this to try to deal with that. There are breakthroughs in technology, whether it's AI, whether it's in drones, that type of thing, that can help deal with this tyranny of distance. But unless we plan for that and we budget for that and we look for what those resources need to be, we're not going to have those in 2050. So I think that's one thing that, whether it's the U.S. or the state of Alaska or the Coast Guard in the specific case, that's something I think between now and 2050 we're going to have to really pay attention to, because these technology breakthroughs are happening now that we need to take advantage of. Yes, ma'am. There, and then Sherry. Yes, ma'am.
So just adding on to the infrastructure that we might want to hope would be in place by 2050 in a case like this, in these newly accessible water areas, would be the ability to quickly gain access to trajectory analyses in the atmosphere and also in the ocean, so that when we have hazardous materials traveling through these areas that are hazardous themselves, we know where to turn to get a quick analysis. Okay, let's say there's a release of a contaminant. Where's it going to go in the atmosphere, or where's it going to go in the ocean? And have that in place ahead of time, so that we're not looking through the yellow pages trying to find a good ocean modeler.
Right.
When something like
that's
this
exactly,
happens.
I think, what hopefully in the next few minutes we're going to see come out as exactly the need for that type of thing. That's exactly right. Yes, sir.
That's the point I was going to make. I'll take it to the next step. Part of this issue is if you're going to be dealing with a search and rescue right off the top of the bat with in a situation where you have a storm, you need to know whether or not you can get your assets safely there. So you're going to need to be able to know whether or not you have what the current condition of the atmosphere and the ocean sea state is, what the near-term state's going to be. And so we're already seeing that in terms of the infrastructure that's there, a lot of the infrastructure that deals with the United States for weather monitoring and forecasting is really optimized for the CONUS in the mid-latitudes.
Exactly
so
right.
You have the goes east and goes west loitering over the mid-latitudes, but the amount of satellite data available over Alaska is not nearly as much or not nearly as often. And also the surface network and the upper air network are very, very sparse there. So that is already today a problem for our National Weather Service people, as well as those, the Air Force, that are trying to forecast and observe in that area.
That's a great point, and that's exactly what these people are going to need in 2050 when this happens, and it won't be there unless we start working on it now. Yes, sir, real quick, and then
Real
Sherry,
quickly,
you got it.
So by 2050, we need to transform our idea of infrastructure planning, right? Because presently, infrastructure planning does not come with emergency response planning. So infrastructure that is being planned now does not come with an emergency response plan. That's up to the communities. So by 2050, we need to transform how that works.
Boy, that's a very, very good point. That's an excellent point. If we had a couple more minutes, I'd want to drill down on it. But Sherry, let's step up the scenario.
Okay. All right, next move in this scenario is, nuclear icebreakers are steam turboelectric, and during the collision, the electric motors are damaged. The icebreaker loses power and grounds off a populated island in the Bering Strait. The potential for release of radioactive contaminants is a realistic possibility, and there is potential for seaborne contaminants to be carried north and then eastward in the Alaskan coastal current, or airborne contaminants to be carried to Alaskan coastal and inland regions. Okay, first question associated with this next development is, what emergency response systems in Indigenous communities would be called upon for response to a nuclear maritime incident? And do these emergency response systems have knowledge and effective communication lines with state and federal level agencies responsible for radiological incidents? Gail and Austin, as our residents from the Bering Strait and from the region, would you like to take a first crack at that?
Sure. Well, first of all, I hope that we, transform another idea about response capacity, and that is that we have the political will now to put in place robust response vehicles, right? We think that, we hope that if we put terrestrial infrastructure in places that will increase our safety. That's not necessarily so. We can have the largest, most robust response vessels there now, right? So aside from that, if that's the case in 2050, we also need to look at how we involve local communities. So when you look at the way DEC or others or Coast Guard respond to incidents in Western Alaska, the local person is usually one of two people, the VPSO or the president of the village corporation or the village, the tribe.
Can you
The village public safety officer, right?
Thank you.
So that, but however, that VPSO person has other public safety tasks that cannot take them away from their safety role, right? But unfortunately, we tend to do that. If it's the president of the tribe, well, do they know all of the things they need to know to help the response? Maybe, maybe not. By 2050, we have to change that the dynamic and put those things in place.
Gail.
The other thing is that would need to be ascertained is whether there are assets in place to deal with a situation like this. And I don't, one of the things to remember too is that Alaska is a really large state. And so if there are assets distributed throughout the state, the question then becomes how long does it take to get those assets to the location of the island and what happens in the interim. If I lived on the island, I would want to know, and I think communication with folks on the island would be really important. I would want to know whether, what kind of contaminants we're dealing with, whether it's blowing away from the island or coming to the island, whether there's a need to evacuate the island. I think that there would be a real need to ensure that whoever is determined to be in charge there, and I think that if you look at the villages, basically people know who to turn to if there is an incident, and ensure that that person is kept in full communication with whoever is in charge on the outside so that they can plan and prepare for whatever needs to be done.
Thank you. Randy, you are our nuclear expert from Sandia.
With some background in commercial nuclear safety and emergency response of this sort. And I just want to add, because it seems to go with the flow of the conversation, is that in the U.S. commercial sector, it's up to the plant operator to decide, are we in trouble? Are we going to be in trouble in 2 hours? And then they decide whether there's going to be a site emergency declared, and then what happens next. And then I believe it turns to the governor, essentially, to make a call. Are we going to evacuate? And there are rehearsed, planned ahead evacuation strategies that include staged evacuations where special needs, general population, prisons, schools, things like this are handled in an orderly manner, or even more protective measures such as keyhole evacuation, where if you know that the direction of the wind is going to take the effluents in a certain direction, you won't evacuate in that direction. You'll evacuate in a different direction. You may need to change your strategy. So these things all have to be worked out ahead of time, and generally the communities prepare for such an evacuation. And by the way, the contaminants are iodine and cesium, and those are the two poster child threats. Iodine presenting a very near-term high radiation dose. It's often the lethal dose. And then cesium-137 with the 30-year half-life. Takes 100 years for that to drop a factor of 10. So this is the land contamination and the threat to the fisheries and the threat to the economic consequences.
Okay, and we're going to get to drill down on some of those questions a little bit more as we go along. Mark's got a naval background and done a lot of work on Arctic shipping and foreign direct investment.
Thank you. Since you've mentioned nuclear, in my mind, that really ups the ante considerably, and it transforms the incident from a search and rescue issue to one a la, at least of equivalent stature as the Deepwater Horizon. It's not something that just involves the United States. It involves the United States and Russia. It involves the United States and some country, that the flag of convenience operator, as well as the Chinese government. And that and it would have to be a seat of government response, and a principal federal official would have to be appointed as quickly as possible to go in and do immediate triage to assess the status of the containment aboard the integrity of the reactor, and whether or not evacuation. And also you would want to decide whether you want to establish containment areas or exclusion areas to prevent local population or shipping from getting nearby for fear of radiological contamination. And so I think that once you inject that, and then you also have to consider the potential, and the State Department would have to be heavily involved in this, as to whether or not you might have to involuntarily board some of these vessels in order to not to seize them, but to make them safe, to try to contain something from getting out of hand.
Becca from the Naval War College.
I think one of the first priorities would be to open up ongoing channels of communication with both the Russian and Chinese governments here because of the sensitivity of the issue. The Chinese shipmaster would have almost certainly have called back to Beijing before calling into the Coast Guard. So I think it would be safe to assume that the Chinese government would be fully informed of what's going on. Ditto Russia, these are very significant assets, and I think Mark makes some great points about the priority would be securing permission to go on to that vessel to offer assistance. If there were any sticky points there, things could get very difficult very quickly. If we had, a Russian government-owned icebreaker in U.S. waters, that's a real knot, and the best way to untie that would be to have a really clear channel of communication at a high level between Washington and Moscow, because on the Russian side, there would be a number of different agencies potentially involved. That ship would belong to Rosatom Float. The Russian Coast Guard would be operating in the area and responding. There's a number of other Russian agencies, their Ministry of Emergency Situations, their Environment and Natural Resources Ministry, that would potentially also be involved. And so getting up to a high enough level that on the Russian side, somebody could get all of those agencies corralled and get some straight answers, I think would be really important.
Complicated situation that requires early warning and practice to anticipate. Okay, who hasn't weighed in here yet? Okay, Lawson.
But there is practice. It's been practiced for five decades. The U.S. Coast Guard in Juneau communicates weekly, I think, with the FSB now and the Russian Coast Guard. So immediately, I'm sure that Admiral Bell would communicate with his counterpart on whatever the Admiral is in 2050, would communicate immediately and keep those ties. So it does tell you at the practical maritime level, we need to have this kind of relationship with the Russian Federation through the decades, and not just at the highest level, whether it's there or not. But at the practical maritime level, there are all those connections today, and they've been here for at least 5 decades through the Soviet era. And so I think working those issues and being transparent early on in a disaster like this is very important.
Okay, we're going to go on to the next question, which is that given the potential for radionuclide release to both the ocean and atmosphere, what do we need to know about regional ocean currents and atmospheric circulation patterns, and how and where contaminants could potentially be transported along the Alaskan coast and into the interior? And do we have the modeling and analysis capabilities today to make accurate predictions? Okay.
It all depends what you mean by
Mike,
accurate.
Austin, and then I know Jim, we're going to get you in here on this too.
So as I mentioned before, the level of observing and analysis in that part of the world is not nearly as good as it is in the continental U.S. and other places, not just from a radar and surface and upper air, but as well as from the satellite. So I would say that our ability to predict this would be limited today. Hopefully by 2050, we will have upgraded our observing network based on the ability to field it as well as prioritize the area. Secondly, the modeling aspect is more complicated there. Without the observations to feed the model, you're not able to provide as accurate a forecast as you would have otherwise. So the other part is there is complicating factors. There's a lot of terrain. There's also sea ice. So this looks to me like if we're going to do this very accurately, except for a very short period of time, we need to do this in a coupled model. So we heard from Marika yesterday in terms of the climate scale. This is really not much of a different problem for a medium-range forecast scale. And this is a problem that is complicated and is probably beyond the capacity of any one agency to do by itself. That's why there are communities here. And so I would hope that by 2050 that the U.S. government would have gotten their act together and helped build a community modeling and observing system for Alaska and the Arctic region that we're all working on together. Because what good is it if the Air Force is getting one forecast, DHS is getting a second forecast, and the locals are getting a third forecast, and they're not coordinating their efforts? It has to be, frankly, just as important they have the same picture as it being an accurate picture.
Thank you. Austin?
So there is always or usually a subsistence activity occurring in this region, right? And if this emergency were to occur in a nasty time of the year, what we now typically call the shoulder seasons, it's still going to be nasty. It might be ice-free, but it's still going to be nasty. If there were a release, we might be also dealing with a marine mammal stranding response. And there, in region, in consultation, in collaboration with NOAA, NIMFS, we've already looked very briefly at the beginning stages of what a large-scale marine mammal stranding response would look like. But we haven't looked at what it would look like if it's a nuclear incident.
Okay. Jennifer, and then Church. Okay, and then
So
John.
I completely agree with the need for a much better observing network in these new regions where shipping is going to be taking place. And in addition to that, I think starting now, looking forward to 2050, we're seeing a climatology of storms in the Arctic that's changing. So as the ice recedes from the shore and stays away from the shore longer, it's changing the tracks of storms. The Arctic used to be considered a graveyard for storms. It's not that anymore. And it's because when we expose this open water, especially in the wintertime, we set up these locations where there are these huge differences in temperature between, let's say, the land and the water, or between the water and the ice edge. And those big differences in temperature are like energy sources for storms. And so we're seeing storms not just move up there and not die, but we're seeing them regenerate along these edges where the temperatures vary so much. So there's a lot more research that needs to be done now in order to prepare for 2050 when ships are planning to go up there. It's going to be a whole new climatology that they need to think about, especially in February. That would be the time when this would be the biggest change that I would say.
Right, so the oceanographers and the meteorologists, they all going to have, and the weather folk, all going to have a lot more work to do, informed by the science that you've just described. John White, former Navy oceanographer.
Thank you. And let me, I just want to sort of amplify on Jennifer's comment. While there's a lot of churn going on in 2050 over whatever media we're using to do our 24-hour news cycle at that point, people are going to want to know, is there radioactive stuff being released? Maybe the Russians might say something along the lines of, we got it under control, there's nothing to see here. Maybe people might not believe that. What we know is that we are developing technology now, especially with miniature drones, things that we can put in the ocean in very short time scales that can measure, can go in and detect, measure, then monitor, and even help to accurately predict. Are there things in the atmosphere and the ocean? Where are they going to go? At what levels they are? So I think we need to make sure that we are thinking about in our research in terms of technology and science, how are we going to address a myriad of problems like this, whether it's radioactive contaminants, whether it's oil and gas, or whatever it may be. We know we're going to have the technology, but are we thinking the right things in terms of all the bad things that might happen like this, and making sure we're really funding at the international and national level the type of research and technology development that will allow us to address these problems?
Okay. All right. Mark, Randy, Becca, then we got to keep going on our questions here.
This is very quick, and this picks up on what John was just saying. I think in this scenario highlights the fact that we have needs for research and technology in which demand greatly exceeds supply and the ability of one country, namely the United States, to pay for it. We do have an oil spill response agreement, although there's not much in the way of any kind of funding commitments. And I think if we're looking forward to 2050, we need to fortify that agreement to ensure the other coastal countries in the Arctic that they begin to commit more funding for research and technologies and perhaps pre-positioning of assets to be able to respond to something like this.
Randy.
And kind of just quickly to add on to this issue of prioritization of what should be preparing for. And again, referring back to the commercial reactor community, all nuclear power plants in the U.S. are required to perform a probabilistic risk assessment.
Right.
And this is a broad scoping assessment of all possible threats, internal events, things that break, external events like weather, and by taking a broad systematic look at this, we can ferret out what are the drivers, what are the ones that the tall poles in the tent, what do we really need to worry about? And so this is something I would like to suggest that somebody take on the role of doing a risk assessment, a risk study on something like this.
Good point. Okay. Becca, did you want to jump in on this?
Think about modeling the environmental response to some kind of nuclear release in this area. I think it's important to remember that in the 1960s, the United States government proposed blowing a deep water port in northern Alaska using a nuclear bomb as part of the Project Chariot. And that project came very close to being realized. And as part of the studies in support of that, the AEC actually released radionuclides into the environment using some controlled explosions near Point Hope, I think it was. And then they studied the response and how those radioactive materials went through. And they found that since the food chains in the Arctic ecosystem are quite short, radioactivity actually moves through the ecosystem and into the human inhabitants eating foods from the lands very quickly. And so I think that legacy and that history should be really at the forefront of our minds as we think about doing more studies and research and preparation. And I'm going to echo a point that Lawson made about the importance of transparency here, because we're not coming into this with a blank slate. And in our efforts to become better prepared, I think working hand in hand with the communities in the area to make sure that they are involved from the start would be a really important best practice.
Yeah, so the nuclear legacy in Alaska from prior activities is important in how we think about the future and how incidents might unfold in the response. That leads us well into the transition, which we've already started. We conceived this as the first part being about the scenario, how it would unfold, and in some ways the operational response, and then the second part being about the research and what we need to understand now so we can be prepared. Of course, we've gotten into that somewhat, but let's go fully into that now in asking what planning, research, and policy actions had they been taken 25 years earlier, okay, would significantly strengthen situational awareness, effective communications, and operational response to this 2050 Arctic incident. And Jim, you have a question that's been submitted on this.
From this, in the Slido realm, which I urge all of you to use to ask questions, Francis sent in something I think is important to state right off. And Francis said that key assumptions are being made about capabilities in 2050. Communication, response capabilities, coastal facilities, etc., to make this response successful. It would be great to document these so we can prioritize them now so that they exist then. And that's what we're trying to do. And I think that's another task, I think, that needs to be taken on in the first instance, and that is trying to do a kind of a stock taking to document what we have now and where we need to go. So Francis, thank you very much for sending that in. There are some other questions that have come in that I think have been answered about Russia and other aspects to this. Let me, if I may, jump into a real quick question for the Coast Guard. You know, when I was up here with my first question about the networks and within Alaska, between Alaska and the U.S., we talked about first responding, and you all laid out a great point about how ready the Coast Guard is, the links that are there, that this is that at least in this first move was a standard search and rescue maritime emergency that you all are very well exercised and capable of taking on. We upped it with this nuclear aspect, if you will. And so going back to the Coast Guard, as that, you know, as I think about it, and I could be completely wrong, but certainly given the geography and the size of the Coast Guard presence up there, things are stretched pretty thin, particularly in bad weather like this. As the skipper of that Coast Guard vessel that reaches the island first, how well equipped do you think that skipper is to provide some first responses to what's happening there? We talked about the drone aspect, where you can get that from a drone also that can go around and take measurements. But, you know, I think it would seem that up till now, a lot of U.S. Coast Guard training deals with a standard search and rescue problem set. It's great that NORTHCOM is looking at exercising during bad weather, but if that skipper is faced with a potential nuclear problem with a Russian ship that's probably unfamiliar to all of us, this icebreaker isn't well known, I'm sure that skipper on the bridge doesn't have the blueprints to look, but that skipper is the first one there. That skipper is also having to talk probably to the indigenous community. It could be that tribal leader or some of those folks are trying desperately to talk to the Coast Guard to find out themselves what's happening. Is the Coast Guard ready for this kind of thing in that region, or is this something that we have to work on between now and then as well? And this is no slam on the Coast Guard. But truly, this is no slam on the Coast Guard at all. I mean, the Coast Guard does heroic things up there. But as we're looking at the future, was the future in your planning also including something like this Russian icebreaker?
I can say that, you know, a lot of large incidents at sea, you have more in common than there are differences. You know, if we have a ship that's grounded, we have a potential pollution incident. Certainly, a radiological incident is a really unusual and a different thing. I can say that our ships and we have our units do have a radiological detection capability and a protection, and the Coast Guard does have a response function. I would also say, as soon as it becomes clear that it might be a radiological incident, you know, this becomes a national incident. And that skipper on the Coast Guard ship, you know, at sea will do what they can, and the Coast Guard will do what they can. But we also have linkages and a process at the national level. We call it the Maritime Operational Threat Reduction Interagency Process, to call the experts and to bring the right forces to bear. So at that point, I think Admiral Bell and the Coast Guard would look to form what we call a unified command. And a unified command is under the National Incident Management System. it's a way for people with different authorities and different resources to come together to address complex problems. The Coast Guard doesn't have the solution to all of the problems you're discussing, but we have a lot of capability, and we would look to partner with others.
And you might not know, but has this been exercised? Is this something, I think in my mind, as that unified command comes together, which is absolutely right, with other players, who normally might not do this kind of stuff, but they're coming into this unified command because it's a very specialized problem that we've got. I guess those folks that are coming into this unified command, do you think they have the right resources coming in too? Or would you have folks come in and they'd say, hey, I was assigned to unified command, I just flew in from Washington, and I really don't know about nuclear stuff, but I'm here representing, whatever agency they are. I mean, how deep do you think the bench is that when Admiral Bell says we need a unified command, we got to move fast, I want you to do the reach back to the scientific community and others in Washington, bring these folks in. I'm wondering how deep that bench really is, and or will people show up saying, yes, it's important that my agency be here and I'm their rep, but I really, and I know there's not a real answer to that, but has this kind of thing been exercised?
There is a real answer to that. So I'll go back to Deepwater Horizon. So that stood up very quickly. The National Incident Command structure stood up very quickly. And one thing on Phil's point, so just because this is a nuclear incident, anything in the Arctic is going to be a national incident, quite honestly. It doesn't have to be nuclear to elevate to that level. But with the Deepwater Horizon, we stood up in headquarters. You had the command centers down in Houma, down in Louisiana for that, but also in the D.C. area. We stood up Interagency Solutions Group, where we had a table, a big square table, where we had representatives from at least 20, if not 30 agencies, all with roles in the response, so that we were all in one room, could quickly communicate with each other, pass information up and down the chain of command. So that structure is there, and it will be put in place very quickly. Now, for something like this is a bit of an outlier, so there will be others that will be added to that, obviously, but we have the connections in place, and those will happen very quickly.
The question becomes, is the stuff that goes up and down the chain of command good stuff in terms of the scientific data and that type of thing?
And that's where NOAA comes in for sure.
So I was going to actually bring this up in the previous question, and that is, how do we do a better job of sharing information and science with Russia, for instance? Because of the difficulties with Russia, we have sometimes some real problems getting with our corresponding Russian scientists. And I think in this particular situation, to have the Russian scientists, their data and information available for the response is pretty important. Otherwise, we have a whole side of the strait that is not being used appropriately in terms of the data and information. And so there are attempts to begin to try and work better with the Russians on the science. I think there's a modeling conference maybe that Church is putting on this fall that will include Russians. But I think that's a real weak point for us. We have not done a very good job of establishing better relationships with the Russian scientific community.
That's a great point.
So the Russian thing, that's a thorny subject all in itself. But I want to relate something based on my experience with the accidents at Fukushima. And that was the first signal that there was a reactor meltdown and a release of radioactivity was the next day when the Unit 1 reactor building exploded. And this was captured on TV, everyone's seen it. But up until that time, it was pretty much a fog of war situation. The plants were in station blackout, which means there's no AC power, there's no DC power, there's no lights, and there's no HVAC. So it's a very confusing situation. It's very difficult for those people on board ship to know what is the state, is the core being cooled? Fundamental questions like that. So you may, as soon as a reactor is at risk, you may need to be prepared for the worst case scenario in advance of any declaration by the captain that, oh, it looks like in a couple of hours we're going to lose this thing. And by the way, losing the cooling on a reactor of this type in shallow water is going to have serious consequences.
Let's just add to that for a moment, because we have a question here that came in on autonomous technology was key in responding to the Fukushima disaster, and what role would it play in 2050 to prevent exposing more lives to danger? And we know that autonomous systems are playing an ever larger and larger role in helping us understand not only response, but changing ocean and other circulation patterns.
And I'd like to add to that question, and that is, it's great to have an autonomous system, whether it's a drone or whatever it might be. But if Alaska is not having, or the Coast Guard for that matter, are having trouble on the Hill getting budgets for this, 2050 guys could find themselves in the same place they are today because the money wasn't there, the systems weren't purchased, or they don't operate in the Arctic environment. That's what would worry me about that.
Yep.
I'd like to tackle this, if I could, a little bit to what I was trying to get at a little bit earlier, but strategically in unified command, the audience may not really understand clearly what that role and mission is. What does the term unified command mean? Essentially, is you assemble a team led, in this case, by the United States Coast Guard at a flag level, so an admiral, 2, 3, 4 stars, depending on how significant, how fast they got, but ultimately senior leadership in the U.S. Coast Guard that has departments and agencies, the United States government, federal government come in, and they're all going to be working in addition to the federal government. You're going to have a component of the state officials. You're also going to have components of local officials, local public officials that would be a part of this unified fabric. Everyone's bringing the responsibilities and authorities, and essentially to try to help essentially establish a series of lines of activity and efforts to address the problem. One of these things, and getting to what you asked back there, I could envision in this, the idea of autonomous systems is to reduce the human footprint in responding. So you can remove people from at least from the on scene and back them away and put autonomous robotics on scene to deal with this so you don't put life and limb at risk. Meanwhile, you still have an evacuation problem. I'm worried about the people who are living on that island, that we need to figure out, working with the public officials on that island, the best evacuation plan of activity for their own safety. But doing this, so not giving orders, but working with them to try to say, here's the threat if you remain, here's the threat if, here's the risk reduction if you depart. Getting vessels on scene, whether they're air or surface vessels, to get people evacuated away from the scene of danger. So essentially, the unified response in some lines of activity, smart people from across the federal, state, local community to make decisions to reduce the risk of the problem of the vessel versus reducing the threat to the people who are actually in the vicinity of a potential catastrophe. Over.
Well done. Yes, ma'am.
Also, we're not going to be the only ones potentially using autonomous technology up there. I can very well imagine the Russians sending a drone in to take a look, and if we've got a Russian drone entering our airspace, we're going to have a decision to make about whether to allow it in or to shoot it down.
Drone versus drone, that'll be really cool.
Right. And so it's, that would add a layer of complexity that it would again argue for having an open channel of communication, because, if they start sending unmanned technology in and we don't permit it, then this incident could escalate even further.
I think with technology today, if a satellite circling the Earth can take a photograph of someone's license plate, that probably the U.S. military could move satellites into position, hopefully fairly quickly, to at least get a sense as to what's happening on the ground. But in terms of actual boots on the ground, we Native people have the highest per capita service in the U.S. military, and I think that you would find that there would be people, veterans and others in those villages who would be willing to put their own lives at risk to, if needed, go and take a closer look at what's happening on that vessel. And I think that would be, probably particularly helpful in assessing the risk and everything.
Yes, sir.
Jim, so from the Coast Guard perspective, a lot of times we talk about autonomous vehicles or drones with the 3 Ds, dull, dangerous, and dirty. Those are the jobs we want them to do. I can tell you right now, we've flown drones off of Healy, or we've tried to. More often than not, we're limited by the environmental conditions. Simply the winds are too strong, they've iced over, and we've crashed them, we've recovered them, we've never left them out there. But it's an extremely challenging environment. What works in the lower 48 is probably not necessarily going to work in Alaska, so
Right.
that's an area of focus.
Right.
The other thing is, you mentioned a while ago about the skipper of the Coast Guard ship. I'm wondering what Coast Guard ship that would be. Hopefully by 2050, we've recapitalized our icebreaker fleet so that we have 3 heavies, 3 mediums. Please pass that along to my leadership so they know I got that plug in.
Is it
but
recapitalized to your satisfaction yet there, Shannon?
But we do have to have the ice-capable assets, and it's not just ships, it's planes, it's helos, it's everything. You know, again, what works in the lower 48 may not work in this environment. You talked about being in a storm environment. It's going to be an extremely dangerous situation, and you're going to have ice-capable assets to be able to do something in this region.
And, you know, that's my concern about, we've heard about the Unified Command. Church laid out a very, very good wiring diagram on how that works. The reach back to Washington, although I have to say, having Washington people show up in Alaska and say, we're from Washington, we're here to help, that doesn't give me any real good confidence. But I think that's exactly the point. We can make the wiring diagrams and get the command structure done and even exercise it. But my fear is whether it's just an icebreaker or just another Coast Guard resource out there, or the autonomous high-end stuff, if we're not going to get money out of Congress, it's not going to be there. And this situation, should it occur, we're going to have, maybe we won't have a skipper, but if we do, that skipper might not have a lot of resources at his or her disposal to begin what is a huge national problem, but the on-scene person is that Coast Guard person.
All right, I want to read a couple of questions and comments that we've gotten here so we can bring in comments that we've received. Okay, Molly McCammon of the Alaska Ocean Observing System observes that Congress last year appropriated more than $1 million to install high-frequency radars in the Bering Strait to make available near real-time ocean circulation observations. AUS is installing the pilot system later this month. So I would, we can open that for discussion in connection with kind of what sensors and sensor systems do we still need, you know, to advance the kinds of observations and data we would need to respond to this situation. And also, to be fair and bring in some others, we also have another comment for an inclusive exercise, which we've called this. The panel lacks diversity. I'm just going to put that out there. We've tried, but we could be more diverse. Yes, more women and more women, more Indigenous people. And so, yes, but that's the trend we're moving, and we can always do a better job. And we also, I observed that at the beginning. That's why I asked Denali and welcome you to jump in here at any time in terms of the youth element or others here from the audience who want to bring in that inclusive, diverse, if you want to share a different perspective or a different comment. So those are two that, and then one other question here. Looking backwards, do you think that incidents like Exxon Valdez followed the same storyline, and did the response happen as planned for such a scenario that should have been well anticipated? Okay. Lawson.
Yeah, back to this basic infrastructure investment by the Congress. You probably all know that only 6 or 7% of the U.S. maritime Arctic is charted in international standards. So between now and 2050, that skipper of the ship that is responding needs to have some modern charts aboard as a basic 101 maritime tool. Besides the basic infrastructure of Arctic port, ACE navigation, we've talked about communications and a robust observing network, but a whole bunch of tools that relate to the practical maritime operations, which are increasing not in 2050, but today, at least on the Russian side. And of course, we also lease offshore. We've leased in the past, leased in the future. Still, the place is not chartered. Still, the place doesn't have robust, what we would consider robust maritime infrastructure for a emergency response or environmental response.
Hey, Jim and Sherry, one thing I would offer is that if one vessel master's name is Ollie, the other one's name is Stan, and they're looking and saying, another fine mess we got ourselves into. So what we should have been able to do to avoid Ollie and Stan getting the vessels in a fine mix is something I was thinking that Lawson was going to get to, and it is by 2050 having enforcement mechanisms for the International Maritime Organization's Polar Code that gets into the fact that decision support, what are you doing putting vessels in a perhaps a no-go situation? We have so much at risk where folks are entering into a storm as opposed to taking safe refuge. And instead they put themselves in a spot where they put the community at risk and really putting themselves at risk by allowing themselves to steam into a situation where they should probably not have been there in the first place. Decision support tools to help vessel masters make smarter decisions to reduce the risk that they're putting themselves and the crews and their vessels should be something to be considered. IMO may be an enforcement mechanism to help make that happen.
Yeah, that's a good point, Church. And let me bring out another comment we got and a question, which, Mark, you probably have a thought on, is what's the role of international agreements to restrict transit through the Arctic during times of year at high risk for extreme weather conditions? Mark?
Thanks, Sherry. I'll get to that in a second, but to build on Church's comment, I mean, Yamal is here. It's a major industrial operation. And if you actually look at the level of international participation, there's actually 6 large oil exploration fields, multiple wells. So this thing happening it's going to happen. It's God forbid it doesn't, but when you look at the level of industrial activity that's occurring in Yamal, this is hardly surprising. The nuclear angle, of course, is something that I would argue is somewhat unexpected. In terms of what should we have been doing looking forward, or actually looking back a little bit, yes, the International Maritime Organization, I think, needed to play a much more aggressive role in terms of looking at the Northern Sea route. Should there have been efforts to work collaboratively with the Russians to try to establish an international rule set like that's present in the Turkish Straits, to deal with safety of navigation, to deal with possible suspension of transit during periods of bad weather. And so that would have required working with Russia collaboratively 5 or 6 years ago. The second thing is the Polar Code. The Polar Code is good, but there's problems with it. There's nothing to deal with how much will a ship owner pay in the event of an accident. In the case of an oil tanker, at least based on my research, the best you could possibly get is $2 billion. And that's a drop in the bucket in terms of what one of these incidents would cost. There's also no mechanism to ensure that states are following the Polar Code because of the principles of flag state control. There's no port state control agreement as of yet, and that's something that needs to be put in place. And last but not least, unlike in the North Sea, where there's an OSPAR convention among the various states there that deals with response among the countries and also cross-liability schemes so that if there's a claim that can be quickly dealt with, there's no systems in place that would address the Arctic environment. And those are things that we need to be looking at now.
In terms of extreme weather, I think we had a good example of a good decision that was made earlier today where a tourism vessel couldn't get into the port of Nome because of bad weather. And so what they did was they bypassed Nome and went into Port Clarence, which really isn't a port. It's a natural deep water harbor. And they shuttled their tourists to shore to Teller on Zodiacs and then drove from Nome to Teller to then take those tourists into Nome itself. So I think that there are, thankfully, people out there who realize that in certain situations you can't take a chance, and so there was a good decision made today not to do that. So there are alternatives, even if there is really no infrastructure in place now, although I do hope that the U.S. does invest in infrastructure in the Arctic, because I think it is critically needed, that there are places that folks can go to that are natural harbors and wait out bad weather.
Becca, and then Phil.
I want to echo a couple points that Mark made. In terms of the relationship building on the Russian side, I think Yamal is a huge project. Gazprom is a very powerful player in the Russian system. Those icebreakers are operated by Rosatomflot, which is another very powerful actor. I don't know if the Russian Coast Guard can direct those actors particularly well in that power hierarchy, and policy on terms of transport in the Bering Strait is not set by the Coast Guard. That's the Ministry of Transport. So you've got different actors within the Russian system, and we don't, I think thinking that our relationship with the Russian Coast Guard is going to be adequate to give us entree to dealing with the scope of actors involved is not accurate. I think building more relationships across that system so that if something like this happened, the U.S. Coast Guard could call Rosatomflot and be like, hey, your icebreaker is grounded. Because I don't know if we could assume that the Russian crew on that icebreaker would let the U.S. Coast Guard on board. That would be an interesting question. We should make sure to have Russian speakers on board of that U.S. Coast Guard vessel, right? And you have a line back to Rosatomflot to say, hey, you know, we'd like to go on board. So I think the relationship that the U.S. Coast Guard has built with the Russian Coast Guard is very important and valuable, but diversifying that a little bit to deal with the scope of possible contingencies as industrial development goes forward. Having a line into Gazprom so we could talk to them about turning one of their tankers around if the weather was looking bad. You know, that might be a good thing to think about.
And, you know, it'd have to be reciprocal too with the Russians, where we'd have to let them go on board one of our ships if there was something where that was in the offing, and we'll see if we could live with that. So it's a very, very good point, very important point.
Phil.
So two things. One on the exercise diversity. Certainly, as a Department of Defense guy, welcome stakeholders and partners. I have an Alaskan Command representative here. Raise your hand, Amanda. So talk to one of us. I don't make promises I can't keep. I don't write checks that I can't cash in. I didn't sleep at a Holiday Inn Express. So, but we can certainly entertain how we can make it better. Nobody's complaining of too much time, too many people, or too much money. So our exercise program is a somewhat economical way of getting after some of these wicked problems. To the question about how do we make this important to Congress. Now, this is a Phil Brown opinion, not a DOD opinion. This is just me. But somehow Congress passed a law that required flood insurance when you lived in a 100-year floodplain. Now, I was schooled very carefully by a former oceanographer of the Navy, not the one on our panel, but that doesn't mean it's going to happen every 100 years. It means there's a 1% chance of it happening all the time. So we haven't had 5 100-year floods. We've just had 5 times where a 1% chance came true. If we think that something like this has a 1 in a 500 year or whatever the percentage is of that, maybe that's an argument. You passed it for floodwaters. What is preventing us? What would make it important enough for Congress to consider it? Because you don't buy insurance because you think something's bad is going to happen, because you know it's never going to happen, but you have to buy the insurance. So what can we do to get in the conversation to make it important enough to the legislators to create an environment for safety and security?
Shannon.
I'd like to weave a little bit of this together and going a little bit back to what Church said and what Mark talked about, the international aspect of this and governance piece. So Melanie mentioned it yesterday, the Bering Strait Port Access Route Study. So it's a little bit of a misnomer. It's not about accessing ports. It's about waterways management and deconflicting those waterways. I think Austin touched on it as well. So those studies are open for public comment, and we highly encourage people to comment on those. But what that study ultimately led to were the voluntary routing guidelines through IMO for the Bering Strait region. As the other part of that, those shipping lanes were highly charted so that they're very accurate to reduce the risk of something like this happening. I know the storm was a major incident or a major factor in this, but we also have another one out there now, the Alaskan Arctic Coast Port Access Route Study, which is meant to extend those shipping lanes around the north slope of Alaska. It is open for public comment, and we highly encourage people to go in there, take a look at that, and provide that input. What are going to be some issues regarding the waterway usages around that region, to include, deconflicting it with subsistence hunting and fishing, and about vessel safety. So those are the types of things to prevent these from happening to begin with. And once we identify those shipping lanes, then we will make sure that those lanes are charted to a much greater detail than what we've seen before.
Okay, Denali.
I just want to say on the area of communication and public comment periods, this is something that we're facing with both the draft environmental impact statements as well as something as commenting on shipping marine infrastructure as well. We need infrastructure for communication. When I was out in Bristol Bay this summer, I was not able to communicate and talk and make any kind of public comments on any of the draft environmental impact statements, or if I wanted to communicate my opinion on the marine shipping, because we do not have that access in our rural villages. And so we need to be addressing communication issues in Alaska first and foremost, and then being able to address it out on the ocean as well. Thank you.
Thank you, Denali. That was a very good point. And I want to get, now we have we're getting close to the end here, and there's an important set of questions that's come up around food security and the supply chain in such an incident, about what would happen, what do we need to better understand about ocean circulation patterns and radionuclide transport issues, because we have already an abundant fishery in this area, which will probably be by 2050 even more productive, given the warming waters. And then we also have effects on the inland food supply chain. I recall myself now over 20 years ago in the Department of Defense, at the end of the Cold War, the Norwegians were very worried that sunken Russian nuclear submarines in Murmansk, close to the Norwegian fisheries, were releasing contaminants, radionuclide and hazardous contaminants that would affect Norwegian fishing grounds. And that led to a formal program we ran for 10 years on Arctic military environmental contamination to help the Russians offload liquid waste streams from nuclear submarines. So can we get some discussion on those questions? John and then David.
So thanks. I think that's a really great segue into something that really bridges a few of these. One is that we think about making decisions based on science, whether they are an actual decision, do I take my Coast Guard cutter that close to a nuclear incident or not, or longer term, what's the impact going to be in my waters off of my country, or longer term, what's the impact going to be on the food chain of having these things in the ocean? Maybe that's years even down the road. So what I think we should be thinking about toward the year of 2050, we have the opportunity now to put into place the international structure for what could be a unique and transformational international capability for operational environmental prediction to support a decision framework of all those levels. The Europeans have done it with the European Center for Medium Range Weather Forecasting. The European model, we all watch for the hurricanes and wonder if NOAA's is better or not. I'm not going to get into NOAA's business on that. I have my own opinions. But why don't we have an Arctic operational center that can pool the best scientific resources from all the Arctic nations and others toward the best science-based modeling and prediction of what's going to happen at various time and geographic scales. If we could shoot for that and bring the science community and the diplomatic community together after a lofty goal like that, I think we can answer a lot of these concerns in the future.
Great point.
That's a very good point. I'd like to hear other comments on creating an Arctic prediction, Arctic domain aware. Well, we've got an Arctic domain awareness center, but Arctic domain prediction capability is what
I vote for 3 of those.
Okay. I think everyone's in favor of it. Now we just have to do it.
There's been some discussion around Admiral White's suggestion, so that's something that at least has come up, and I think we could certainly explore. What I wanted to mention is I was talking to somebody from Barrow at one of the breaks, and they were telling me about the interesting new species that they were finding in Barrow. And if you have an incident like this, it's going to be imperative to understand what the ecosystem looks like and what's there. That ecosystem is changing so dramatically that by 2050, if we haven't done some serious work in trying to document the changes that are going on in that ecosystem, we would be way, way behind. And there's so many implications from understanding that. One of the first things that happens when you have an incident like this is whatever the commercial fisheries is surrounding it's going to be shut down, if there is one. Subsistence is going to be a significant issue as well. And so in terms of a research question, the whole where are we going with the migrating species and what's the ecosystem going to look like, I think is incredibly important to, and underlies so many of the decisions that will be made in whatever you do with the response.
Could I add something real quick to this point about the center that I think is really important? And I'm going to read this from Anonymous. Anonymous said that, I thought Gail was going to discuss Indigenous knowledge when she brought up the role of local residents. We haven't heard any mention of Indigenous knowledge with respect to wind, waves, currents, etc., ice. Would someone care to comment? And I'd throw that out for comment, certainly, but I think as we deal with putting together the best in terms of science, and that you mentioned the diplomatic community as well come up, I think having a very strong Indigenous presence and voice on this would be really helpful too. There's a lot of wisdom there, I think, that could help us better judge the weather patterns and all kinds of other things as well.
There's something I'd like to take a comment and hop on that one real quick, and then I'd like to offer for my distinguished colleague Gail for reflections. I think there's this conference last 2 days that really hit on the aspect of the need for a co-equal representation of traditional ecological knowledge and really Indigenous-based science versus that quote of was Western science. Collaboration is really not just collaboration but integration. So, there's a lot of us that are associated with the community of science. Our little center is one that's focused on principally heavily applied research. There's a lot of other research enterprises that are either federally sponsored or academically driven, but ultimately that go between fundamental science and all the way through the heavily applied. Traditionally, that has been within stovepipes. And so how do you find a way to break those stovepipes apart and really get down to the point where Indigenous people who are experts in Indigenous knowledge can sit side by side and co-produce? We've talked about the need for co-producing knowledge between Western and Indigenous-based science, but at the end of the day, we need to be about the business of actually setting a mechanism that actually co-produces as a dedicated outcome, not an applied afterthought. One aspect for this is that our center is just one center in this whole enterprise, is partnering ever so more closely with, as we're funded by the Department of Homeland Security, we collaborate closely with NOAA, National Weather Service, Office of Naval Research, et cetera. But ultimately for us, the more we collaborate with, for example, Inupiat Corporation Science, UIC Science, is one example where you're actually seeing people who are shepherding science from an Indigenous vantage point, integrating that with what we're doing to other research. That's kind of the models where I'm thinking that we need to go forward towards the future. Thoughts on that, President Schubert?
Well, I think that the person who wrote the note really hit the nail on the head. And I was mentioning to Austin earlier that unfortunately I'm kind of on Alaska time, so I woke up at 2:30 this morning and wasn't able to get back to sleep. But Indigenous knowledge is really critical, and I know that there are a number of agencies that do actually consult with our people. My mother is 92 years old, and she lives in Yunlakleet, and I was talking to her the other day, and she mentioned that she has seen many changes in the environment and in Yunlakleet and in what's happening in the oceans and the water. And someone mentioned fish species moving north because of the warmer waters. This past summer in Yunlakleet, we had a die-off of salmon. It was an early run salmon, because the river water was too warm. And fortunately, it recovered somewhat, and so I think that people had a somewhat successful salmon harvest for subsistence purposes. But it is really critically important for scientists and other experts to consult with Indigenous people as these matters move forward. So thank you for bringing that back to the forefront of my brain.
Okay, thank you very much, President Schubert. And now we're going to go to sort of, and that's really started us on our round of kind of closing and wrap-up comments, not required, but if any of our panelists feel compelled to say one last thing, and then we're going to bring this session to a close. Becca, John.
I want to touch on one comment that we haven't addressed yet. Someone asked about Exxon Valdez and the legacy there, and I'm really glad that was brought up because that was 1989. And in the wake of Exxon Valdez, that tanker was single-hulled. So we went to single-hulled after that, and the captain was drunk. So we imposed tighter restrictions on navigators after that. But those were reactive responses in the wake of one of the worst oil-related disasters that we've experienced, the environmental effects of which are still present today in the environment. And so I think we have an opportunity now, looking at the industrial development that is getting up off the ground in the Arctic, to take a proactive, preventative approach so that we don't repeat those same mistakes. And I'm really glad that somebody brought that up. It's important to remember that we can learn a lot from those disasters, and we should use those as motivation to make sure they never happen again.
Yeah, I want to second that point, because we know when there were plans to do the offshore oil drilling a few years ago, and those, when you drill down into those plans a little deeper to see kind of what would happen if there was an incident, there were still a lot of missing pieces in those plans. So, that's, I want to underscore that point, that really we need to bear in mind what those risks are as we go forward with development plans in the region. John, Austin.
I'll be quick. I'll just say we are reminded this season during hurricane and typhoon season that there's no shortage of scientists and others who are willing to put forth their own map projections and predictions on what's going to happen with an event. Going back to...
Got a Sharpie right here.
Going back to the event in the Gulf of Mexico, I was a resident in operating the U.S. Navy's ocean model that was provided to NOAA for Deepwater Horizon. It is important as we establish an incident response framework and unified commands. This is in the U.S. federal territories, so NOAA would likely have the authoritative, science-based knowledge and information about what's going to happen. We need to make sure in the science community that we recognize that and be very careful of what we might tell our good friend who works at Northcom or at CNN on our basis of, well, the loop current is going to erode and oil is going to go up the East Coast and invade all the beaches of North Carolina. It's important to understand that science is good, but we need to work together toward a best answer. In this kind of an incident, the indigenous folks are going to really want that best answer. And we run danger if we give them multiple answers, and I've been there. There's nothing more frustrating than multiple wrong answers. We need to have the best one and recognize that is in the best interest of our indigenous populations as well as our U.S. agencies.
Absolutely. And thank you, John. Right. And that underscores the several comments that I saw come in about how social media and real-time reactions are going to distort, what we know about the facts of the situation in any given incident.
Yep.
Okay.
Wealth of knowledge piece here that...
Who was next?
Sorry.
I think Austin. Yeah. Okay.
Yeah, thanks. I really hope we can do more of these kinds of things because we really, really need them. There are lots of examples, lots of lessons that we can learn from what we already are doing and what we already are responding to. So in the northwest part of Alaska, in the northwest spill area, we deal with some 18,000, 20,000 gallons of oil or hazardous substance every single year, right? And what's often the case in rural Alaska compared to other parts of Alaska is that, like, our oil spill response, the responses are open rather quickly and then close very rapidly. And in the decades or so that we've had oil spill response in Northwest Alaska, there's never been a wildlife impact ever associated with any of those spills. So I would hope that we could have some, that conversations like this could invade the parts of government, the parts of rural communities, so that we can elevate these values and have these value discussions. Because maybe over the last several decades there have been wildlife impacts. We just haven't gone that far and got into them. So I really hope we can continue this kind of thing.
Well, that's a great closing note, and you'll enable us to end right on time to say that we have enjoyed, I hope I can speak on behalf of all of us, that we've enjoyed participating in this kind of scenario-based demonstration exercise with you, and hope we can do it with more of you in greater depth in the future. All right, Denali would give you the very last word here on behalf of the next generation that will be in charge in 2050.
Problems we're handing off.
Okay.
Well, I just want to say, if we want to continue these conversations, and I invite you all to come to Alaska and have these conversations with us in our home area, with our people on the ground, with our elders, and with our youth.
Phil and I'll be there next week.
Okay.
Sounds good.
Thank you. Thank you all.
Yeah, nice to see you.
I'll be back out there in February, so I don't want.
Thank you. We'll now have a 30-minute break. We're 15 minutes behind schedule, so we'll be coming back at 3:45.
Good afternoon. Thank you for coming back for our final session of today. I think one of the difficulties of having so many interesting people in the room is I keep not getting a chance to pee on these breaks. So I realized I wasn't going to make this session unless so I apologize for being late and inappropriate. It's my pleasure to introduce Anne Husbeck, and Anne is the rector of the Arctic University of Norway. She's an immunologist by background, and she's going to make a few remarks about collaborative science. So, thank you, Anne.
So thank you for the introduction and for the opportunity for me to give a 10-minute report from the northernmost university in the world at 69 degrees north. I firmly believe that an educated population is a prerequisite for making good decisions in the future. I think that both to understand what climate changes are appearing, to try to avoid more climate changes, and to adapt to climate changes need an educated population. In this picture, we can see a fjord in Svalbard, a fjord that used to be an Arctic fjord and has now turned into an Atlantic fjord with a total difference in the species living there. The changes are very pronounced. We need, in the Arctic area, to be in a position where we can combine traditional knowledge and research-based knowledge to develop sustainable and smart Arctic communities. I live in an area with very good infrastructure. We have an airport in Tromsø with 10 flights from the capital a day and with very good fiber connections. So we live in the urban Arctic, quite different from what we have seen from others presenting today. In this picture, we see a small island with 300 inhabitants, not very far from where I live. In this island, they have a fish industry exporting for $150 million a year. In this community, our university has helped out making an automatic fish processing line, and we are also engaged in giving this small island a stable electric power supply, which they lack today, with a smart grid and a hydroelectric power. UiT, my university, the Arctic University of Norway, was established 51 years ago. It was in a time where the population is in the northern part of Norway were decreasing, and the competence level, the number of people with higher education was very, very low. Over the years, we have educated like 60,000 candidates from the university. 70% of the candidates stay in the north, and today the level of higher education is 29% in the north compared to 34% in the rest of the country, which is not bad. Today we have 17,000 students in 10 campuses in all parts of the northern Norway, and every year 3,000 candidates are educated from our university. Our strategy is called Developing the High North, and we are based in the north and we educate people mainly for the north. We have 5 areas that we want to be really good at, and all with an Arctic issue in the forefront. It's energy, climate and environment, health, welfare and quality of life, community development and democratization, technology and sustainable use and management of resources. I will give you some examples of the research that is done today and it is done for the future. One of them is the Climate Ecological Observatory of the Arctic Tundra, having one laboratory on the mainland Norway and one in Svalbard. What we observe is that there is a very pronounced climate change, and insects or larvae from the south is now eating up the birch forest in the north. That makes the whole flora and fauna being different, and we see that polar foxes and Arctic grouse are diminishing, and the red fox is increasing in numbers. Also, we are concentrating on methane release from thawing tundra and seabed. When the ocean is ice-covered and the seabed is frozen, methane is probably mostly unreleased. It is there under the seafloor. But when the ice cover disappears and the pressure is less pronounced, methane can be released. Most often the methane is dissolved in the ocean and doesn't impact the atmosphere, but at certain times there are big bursts of methane which can reach the atmosphere and has an impact on the climate. Also, we have a Center of Integrated Remote Sensing and Forecasting for Arctic Operations, and related to discussions we just heard, this is of interest. In the polar area, the satellites can be, the information from satellites can be loaded down 14 times a day, and we do that. We have drones, and we try to implement the information from the space for forecasting on the globe. And in Tromsø, we are now planning a center of expertise in space technology, which I think will be quite interesting. We are also concerned with legal issues, and we have the Norwegian Center of Law of the Sea. And who decides the underwater borders, who decide when areas are ice-free and can be exploited for resources. I think it is necessary, and I think the discussions earlier today have shown very clearly that we need to be, have this area regulated and with laws that are implemented and complied to. We have established an Arctic Center for Sustainable Energy. You may know that the northern part of Norway is fully, they have hydropower. We have hydropower, much more than we actually need, but still we are concerned about having sustainable energy in all parts of the Arctic. So this is a truly multidisciplinary center with a lot of interesting groups of researchers working. Two examples of the activity that I have. The first is a very interesting use of CO2 and NOx from a ferrosilicon plant combined with algae from the Arctic. The algae need CO2 and NOx and cold water, and they grow very fast, divide 1 to 2 times a day, and the biomass can be used for very healthy fish feed. We grow a lot of salmon in Norway, and now we use soybeans as a part of their feed. This is a much more healthy food. And other parts of the algae can be used for other industrial developments also. This is also a good example of circular economy. We have also shown very clearly that solar panels are more efficient in cold climate compared to warm climate. And since we have sun day and night for months, half a year in the high Arctic, it is easily achieved a lot of energy from solar panels. And those of you who have been to Svalbard have seen that in the airport, the walls are fully covered by solar panels in a very high Arctic area. We think that combination of different sources of renewable energy can be used in small off-grid societies, and we are working hard to find this combination which is suitable for many Arctic societies. You have got some examples of research products that is also combined with education for the future. We have to believe in the young people who are going to take decisions in the years after us. And we have to give them the best possible education, which we try to do. We have a lot of disciplines. We are a comprehensive university with special task into Sami, cultural language and history. And we want our young people to be well educated to make those brave and good decisions for the future. It is also to mention that in Norway there is no tuition, and in our university we have students from more than 100 nations. 10% of the students and 17% of the staff come from other countries than Norway. So you are all welcome to recruit students to Norwegian universities, and I wish them all welcome to Tromsø. Thank you for your attention.
Thank you very much. Yeah, if my panel would start making your way up to the chairs here. So we have, throughout the conference, we have three, leave that chair for me and then wherever you want to sit. How's that? Yeah, we have three case histories where we're attempting to give examples of incidents where local knowledge, traditional knowledge, and science informed or failed to inform policy decisions. So we heard some of this yesterday in the case of the Barents Sea fisheries example. In this one, it's an example from Alaska having to do with the traditional subsistence whaling on the north coast of Alaska. And our panel consists of Harry Brower Jr., who's the mayor of the North Slope Borough in Alaska. And he's also a whaling captain. Dr. Michael Tillman is one of three commissioners on the U.S. Marine Mammal Commission, and had a long career in fisheries before that. And Dr. Craig George is a research scientist with the North Slope Borough in Utqiagvik, Alaska. And all three of these gentlemen were involved in this case history, this example of where actually both science and indigenous knowledge were very key in solving what was a very challenging policy both nationally and internationally. So this is a high drama story, you know, it involves information, misinformation, collaboration, and trust. But it wasn't an easy place to get to, that place of trust where I think it resides now. So I think the best place to start was maybe asking the mayor to talk a little bit about the history of whaling among his people, and then we'll get to the challenge that came to that in the 1970s.
Thank you, Brendan. I think you're getting me to start. I was going to make a little joking remark, land before time, about activities done on the Arctic, on the North Slope, or whaling for our communities have been in existence for thousands of years. You know, the resources that we depended on were also utilized to make shelter and tools in the Arctic. These were things, items that we identified with in taking animals. You know, in the Boat whaling, the elders even had names for the whales that they were willing to pursue. Ingutuk was the small, plump whales. Kailalik are the large, flat, slim, slender whales. Then Ikwakrilik is the one, the big 60-foot whales with the shoulder blades, or the can be used for a door and an entrance, the ribs for the walls. These are the kinds of knowledge that were passed on through the whaling activities. So this, it had a lot of history behind the sod houses that were made in the Arctic, for the homes that they lived in were very low. The igloo, the real traditional sod houses that were built. They weren't just located in Barrow, they're in every of our villages across the coastal communities of the North Slope. So this gives you evidence of how long it's been in existence. You know, it's kind of sad to say we're losing some of these sites because of the coastal erosion measures that are occurring now. I mean, recently in Point Hope, the ice cellars and the sod houses that were there are exposed because of the erosion. And the internal structure of these homes were lined with shoulder blades, the rib bone, the jaw bones, and you could see them in as clear as day because of their exposure now. And this kind of hunting has been passed on for generations, generation to generation. I have to say from my grandfather's era even, before that time was even occurring. So my a little background on my grandfather, he was a Yankee whaler. Come up to the Arctic, Yankee whaling, and married into the community, raised children, 14 children, amongst the many grandkids they've had. So it's been passed on from generation to generation over time. I just recently, talking to my children, my two daughters, along with my wife who's here, and my two sons, about what we're preparing for in terms of whaling. It's not an instantaneous action that you take. It takes time in preparation to the day that you're going to conduct the hunt. So it's a year-round activity in gathering other resources as well. Because I cannot say I accumulate these resources in one day. It takes time and effort for all the processes and tedious little findings that you have to identify with to prepare for a hunt. So it's a passed on knowledge from generation to generation and spoken to within the families in preparation. For the food is one segment. Storing is another. Hunting is another aspect. So there's different realms of preparation in attaining the knowledge to be a whaling family. And it doesn't happen overnight. And it takes the whole family at times and even community members and extended community to conduct the whaling activity. So I'm not sure how much more, that's why I was making that little remark about land before time and communicating on how much preparation there is. We're not even beginning to identify with the frame of the skin boat, in the preparation for the skins, in the sinew that's taken from caribou to be braided for thread. There's all the different aspects of whaling that's very important to be shared with. But in pursuant to time and knowledge, I hold comments to you.
Thanks, Harry. So you mentioned that, this has been going on for, I'm using Maya Lukin's scale here, for a very long number of generations. And what, maybe as much as 2,000 years, something like that? And I think I'd like you, Mike, to talk about what happened in the 1970s that disrupted that long span of tradition.
Okay. First, let me explain my position at the beginning of this. I began my career in 1972 as a fishery stock assessment person for the National Marine Fisheries Service, and which I found to be a very boring activity. I was then offered the opportunity to extend my expertise, shall we say, to the serving on the scientific committee of the International Whaling Commission, which was a great opportunity. So I jumped at that, and the U.S. at that time was in the midst of trying to get a commercial moratorium on, the commercial use of whales, and devoting all of its attention to that particular issue. And indeed, that is why I was brought on board, was to focus on assessment of those stocks that were under commercial exploitation and try to ascertain if they were already in need of being protected. And had quite good success with that. Data showed that many of them were overexploited already and could be brought under protection. under the rules of the International Whaling Commission. And during this period, my position here is I was the most junior member of the IWC Scientific Committee, and I was the most junior scientist that was sent to IWC by the United States. And when the bowhead issue came to my attention, it was about 2 years after I'd been on the scientific committee, and one of the scientists said, well, Tillman, what are you doing about the bowhead problem? And I said, what bowhead problem? Because I had no idea, because I was focusing all my energies on commercial whaling. He said, well, you got to go back and read the past reports of the scientific committee. And indeed, you go back 2 or 3 years before that, and the scientific committee was pointing out there was this activity on the North Slope of Alaska. Bowhead whales were being taken by Alaska Eskimos. There were concerns about growing catch. And in fact, there was no information about the status and trends of the bowhead whale population that was being used. And we went back and talked with my boss about these matters, and he scraped up a few dollars and put it into trying to start something going up there. It's a period of very low budgets for science, indeed any NIMS activities, but he scraped it up. And so we began trying to monitor the hunt to find out about this problem of the take. And indeed there were also losses because not all of the strikes were 100% efficient. So there was a struck and loss problem to deal with. And then the other one was, what might we do to try to get a handle on abundance? Well, we had the experience of what was going on with the California gray whale, where we had a counting station and where we had a series of annual counts of the animals passing by. And we thought, and that enabled us to eventually develop an index of abundance. And we thought, well, maybe that'd be the same thing to try to apply here. So we did a pilot study, the first at 76, and reported that out in 77 to the scientific committee. The view of saying, here's this pilot study, here's these counts. What do you think? Are we on the right track? And then some other scientists who were there, instead of responding to my question, where I asked for some help, said, well, we think we have enough information here to do an estimate of abundance. And I was very surprised by that response, because I thought, well, that isn't why these data were collected. Nonetheless, they persisted and they ran with that and came up with this eventual estimate of abundance of 1,300 animals. And so that was what was put in the scientific committee report. There was also a new estimate of what the possible total population had been for bowhead whales. It was projected to have been between 10 and 18,000 whales. So that comparing that current estimate with the past estimate caused worry by the scientists, and especially since the take was estimated to be 100 strikes, 50 of which were landed. So the struck and loss problem worried the scientists. And I was asked, okay, here's this problem. It still persists. Picture looks bad. What is the United States going to do about that? Are you going to take the research and do the management necessary? Can you assure us that these things will be done? I could not, because I'm, again, low guy on the totem pole. And the senior scientist on our delegation said, well, look, we made best use of available data, made use of the best available data. Where have you heard that before today? And so this is put in the scientific committee report. Told the U.S. delegation, here's what the report says. They were caught flat-footed. They never paid any attention to this problem, despite it being in the scientific committee report in previous years. I mean, this problem existed. They were operating under two, so we say, policies at that time. Make use of the best available data, and two, support the recommendations of the scientific committee. And the senior scientist on the U.S. scientific delegation said, we have done these things, sir. You need to do this. And so instead of doing something that a delegation might have done, which is such as try to buy yourself time by saying, wait. The data have been misused. Give us some time. Let us go back home, try to find out what might be done in terms of putting in place the science and management necessary to deal with this problem. They didn't do that. In fact, they didn't object to what the scientific committee has said. I cannot recall that the commission even voted on the issue. I think they accepted the advice of the scientific committee by consensus. United States staying silent. That recommendation being that essentially that the quota be 0 for bowhead whales. This was, of course, as you'll hear, terrible news to the Eskimo community. I don't know how much further. That sets the stage for what happened.
So
we
just
go into the policy consequences at a later stage, if you wish. But it might be useful to hear from Harry and also from Craig their perspectives on the problem at this point in the time scale.
Just let me recap here, right? So we've got 1,000, 2,000 year record of subsistence whaling, and we just heard this sort of odd sort of exchange among scientists in an international forum, which comes to the conclusion there needs to be a moratorium on the harvest. So yeah, I would like to hear from Harry. So tell us about the impact of that moratorium decision on your community and the communities in northern Alaska.
And thank you for the question, Dr. Kelly. I think there's a lot of anxiety felt around the whole, not just in Barrow, in all our whaling communities. Trying to identify with how are we supposed to sustain our communities without whaling? The amount of food that each of the whales provided. You know, these kind of thoughts were going through my parents and my father's brothers who were whaling captains, and aunts and uncles that were the wives of the captains in the whaling community. There was a lot of anxiety among why there's a moratorium on whaling. You know, the formation of the Alaska Eskimo Whaling Commission was initiated at that time to give communications on that we need to continue our whaling practices. It's been in existence for thousands of years. How can this be stopped in just in a short period of time? You know, it devastated people's lives. How are we supposed to plan ahead? If you live the Inupiat culture in a sense of family planning, you identify with the resources availability to each of your families. That it may be a good year to raise a child, have a newborn come into your family at that time because of the amount of resources available to sustain the family throughout the year. These are the kind of family planning efforts that were affected by the communications of the moratorium, and how we even with the structure of the Alaska Eskimo Whaling Commission, the chairman, trying to hold several meetings and identify a process moving forward, had a lot of anxiety built in the communications was sparse. No real means of identifying with consultants to communicate how do we move forward. Without that in place, he committed suicide, in a sense. That it was very devastating to our communities. And what does it mean for the extended families going forward? I can use myself as an example at the time, 1977 was the year I graduated from high school, and the moratorium comes on. And I was trying to ask my father, what does it mean for me not to go out whaling with you? And he says, we're going to change that. We're going to change that. We're going to be talking with the other whaling captains. And there's a meeting being planned by your uncles to bring these other whaling captains into the community to discuss this issue of importance to sustain our communities. There was a big impact and an uproar, in a sense. There was anxiety among families as to what's going to be in the future for us. These kinds of communications I can feel right in my own home, And then going to like I said, I come from a large whaling family. My uncles and aunts that were thinking the same situation. How do we expect our children to raise families when we're in a situation of this sort? The quota was not even developed yet. It gave us a number of animals to be divided by several whaling communities, which was not sufficient. And the moratorium that was imposed on us was out of nowhere. It's just like an individual being arrested and being put into incarceration for something that he'd done wrong. They didn't know what he'd done wrong, I'll put it that way. I think the importance is that we had to cope through this, identifying, and I have to say our communities are faith-based, structured, a lot of prayers going between families, and it was very evident in between the families of how do we get from one day to the next. And it was through prayer and faith and identifying with other resources that's going to sustain our community, the families that were in need. So these were very hard times in terms of communications amongst families in terms of what was being identified as the moratorium.
So Harry Sr. was involved in the formation of the Alaska Eskimo Whaling Commission?
As a whaling captain, yes.
And then,
Important response.
Craig, how did you come into this, and what was your relationship to the AEWC and all of this?
Thanks, Brendan. First, I just want to say it's a real honor to be here and share this experience with people. And I'm kind of reliving 1977. That's when I arrived, May of 1977, just when the moratorium was imposed, and I saw a community in distress. And I was pretty clueless, as most of us were, coming out of the lower 48, and asked a lot of questions. I'd been trained as a terrestrial biologist and was working at the Arctic Research facility there, and began this sort of journey of discovery and learning about Inupiaq whaling and the people and the harvest. And then we had a very pragmatic task. I was hired on, actually, initially by NIMS, but then by the North Slope Borough. And we had this very succinct task to estimate abundance of bowhead whales and estimate get good estimates of reproduction and that sort of thing. And so, as sort of on the logistical side, I had to work, figure out how to do these counts. Now, Michael mentioned that we were doing shore-based counts. And we adopted that methodology to the Arctic, only the shore was the sea ice. So I had to learn how to work out on the sea ice and talk to some of the ice physics people, and they said, talk to the Inupiaqs. That's not our, we'll tell you about compression strength of ice and this sort of thing, but we don't know anything about camping on the ice. I went, okay. So I actually went to your father, who had a huge impact on this program. And I was hired by Dr. Tom Albert. And so began learning what ice types are available to camp on, what are the best places to count whales, what are the safety issues, when does the ice break off, when do we get crushed by the pack ice coming in, all these sorts of things. And we started putting this together. Essentially, learning the ice skills was a prerequisite, doing the bowhead census, as we call it. And then Tom Albert, who we worked for, and Ray Dronenberg that helped start the program. So the importance of developing trust was so important. And Tom Albert, in his, he was trained as a large animal veterinarian, of all things, and a physiologist, but in his plain language kind of way, he said, if you want to work on bowheads, you got to live here. Okay. And he said, I love the phrase, he said, none of this remote control science. Anyway, so I said, I'm glad to live here. And it was really exciting. We started working with the community, and that's when the magic started, when we were sharing information and actually getting some advice. Not to go into too much detail, but we were told very emphatically by Harry's father and a number of senior captains, I know you're trying, but you're doing it wrong. You're missing whales that are migrating through the leads when they're closed, which was a tough pill to swallow for the scientific committee at the IWC. And the whales can break through ice to breathe if the lead's refrozen, as in this case. And the other thing is that you're making the assumption that you're seeing all the whales migrating by within a couple miles of the lead edge. And they said, there's whales distributed way far offshore. So that was our task. And so we started improving the logistics, and we went to some acoustics experts, and we said, can you help us with this problem? And they said, well, if the whales are making calls, yes, we can locate them. They were actually trained in submarine warfare, this sort of thing. And so with them, we incorporated them in, and sure enough, we were able to show huge numbers of whales migrating under ice conditions like this is a refrozen lead right off Barrow. And you can see that hummock. The Inupiaq name, Harry, is of the broken ice. Anyway, there's a specific name for those breakups in the ice. But anyway, sure enough, we tracked thousands of whales going by, and we also whales distributed way beyond what we could see. So then the estimates started to improve. Finally, in '83, I think, Michael, the IWC finally recommended that quotas be set with caution. And incrementally, the quota returned to something that was acceptable to the community. And I don't know how I'm doing on time, but I did want to mention we were criticized. It's like, wait a minute, you are the fox watching the hen coop. You're working with the whale hunters, and there's a lot of distrust of our scientific work. And so that's actually where the science community was a huge help. We said, here's the data, here's all the raw data, here's our, our scientific publications, and put it out for scientific peer review. And eventually, they said, yes, this is real. We're underestimating the population significantly. And eventually, the science caught up with what the Inupiaq people were telling us, that yes, in fact, there are a lot more bowheads than we thought. And then after 10 years of counting, we were able to show another thing they had told us, that the population was increasing. And those are two extremely important things in management, and we were able to show a statistical increase in the population after 10 years of research. So that's kind of the basis of that story. I could.
So could you just say a little bit about the collateral increase in knowledge of the species?
Right, yeah, thanks. Okay, so we had this nice, and I'll call it Inupiat science, not traditional, I think is a more appropriate term in some ways in Western science. In integrating the two, I learned as I was there that, science is science, regardless of the source, and it can be verified and retested, and that, anyway, we began building this synergy. And one thing we did, we had access with the cooperation of the captains and permissions, we had access to the landed whales. And this was a huge opportunity. People in the veterinary field, a lot of people, anatomists, physiologists, this was a mecca for doing large whale science. And so I have to say that it began doing a lot of basic anatomy, physiology, animal health, and out of it came a tremendous number of publications and the contributions to the scientific knowledge, let's say, but if you remember one thing from this, the contribution of the Inupiaq and the Yupik people to cetacean science has been absolutely huge. And I've got a list over there if you want to see it. Probably well over 500 publications have come out. But it was really through that collaboration that happened. So,
thanks, Craig. So I want to get back to you, Harry. So here we are all these years later. You described the very palpable distress in the community when the moratorium happened. This amazing science that the AEWC did, and eventually in collaboration with NIMS, it became a very collaborative effort. So what are the lessons for us from this? What would you say to people going forward? And what is the status of the harvest now and the quota? Yeah, real quickly, and then I want to hear from Harry. Yeah, go ahead.
Skipped over a couple of steps, but I'll put them aside. The things that have enabled us to move forward have been the establishment of the science program and the establishment of the Alaska Eskimo Whaling Commission. And in its wisdom, the federal government signed a memorandum of understanding with the Alaska Eskimo Whaling Commission that has provided the underpinnings for how we move forward and cooperate together in achieving our goals at the IWC. It is indeed the first co-management agreement. It was done back in the 70s. IWC is considered the gold standard by which these Aboriginal subsistence hunts are managed. So that's one of the lessons learned. As we've heard here, you've got to cooperate with those you intend to manage. And they have to be part and parcel of the development of the goals and objectives for those commission meetings, and in discussing the strategy and tactics for obtaining them at those meetings. And so that is second nature for the U.S. delegation these days, to maintain that full cooperation. Just to finish up, We failed, that commission, the U.S. government failed absolutely to inform the Eskimo community about this impending problem. And never do that. I can never forget the first meeting as a brand new commissioner said, come on, we got to go up there and consult with these people. And oh, that was terrible. And no absence of young people there, no absence of bitter comment there, and well-deserved. And I came away with that absolutely convinced, quota or no quota, these people are going to go whaling next season. And I so advised the commissioner, and I suggested a way forward, but in their wisdom, they pursued some other options, and that's the other thing. There are always options to a problem. You have to figure them out. And if you can't do it, find someone who can do it for you and hire that person. That's something I learned in my career. For example, the U.S. could have pursued the process of objecting. There's a formal objection to a regulation passed by the Commission. But the U.S. wouldn't want to do that because it had never done so before. It would be embarrassing for the government to have to do that. There is also the option of, well, why don't we just simply manage this hunt under the terms of the Marine Mammal Protection Act? And again, that was rejected because the U.S. had always adopted the idea that anything dealing with whaling had to be through the international body. It would support the international body, and besides which we would have had to amend the Whaling Convention Act to make this possible, and it wasn't clear that we could do that. And then I offered them the option of, well, you have a special meeting coming up, it's on another topic, but you could put this on the agenda. And you could go forward with a plan saying, okay, we promise to you, here's this plan for undertaking the management and science necessary to manage this problem. And anyway, that set the policy. Not right away. I was ignored at first. I was the junior guy, as I said. But that's the other thing, is there are always options. Keep trying to find a way forward and work with the people to make it happen. That's what I learned.
So there are a bunch of good questions coming in from the audience, and I think maybe we should turn to those because I think they're going to bring out some. Yeah?
Well, I was just going to support Mike in saying that, oddly enough, the NOAA-WC agreement, you and others, the community put together, is still the gold standard of true co-management. And it's a pretty remarkable thing that at that time they were able to do that. That was my, I just wanted to make that point.
So, Harry, one of the questions that came out of the audience was this: with the climate change affecting hunting practices, what program has Utqiagvik developed to adjust to the new conditions we are facing? And if not, what are we prepared to do?
How many hours do we have?
Let's see.
Well, so there's your timer, and there are other good questions. So.
And thank you for the question. You know, it's not something that we take very lightly, but I continue to utilize myself and my family in my teachings to my whaling crew. Our tools are still applicable today. They were built by our forefathers to use these tools. Onak is one. The harpoon for hunting seals, walking with that on the ice is still of importance because of the global climate change effects, the thinning of the ice. And using the tools that we've been given by our forefathers are still applicable today to making sure that the ice conditions that we walk on are safe, to be supporting our whaling crew as an individual. Myself, walking on that young ice to get out near the open lead, we're going to be able to use that unak. And what does it mean? And how do you gauge the ice conditions when you're using that tool? And you jab the ice one time and it goes through, it's not safe to go through. But then you take another 3 steps forward and finding a different location and jab that ice and you hit it 3 times and it doesn't go through, it's able to sustain your weight. So you're able to walk on that ice. So these kinds of tools are still applicable. To the modern conveniences that we hold today, you know, that sometimes these tools you want to leave at home. A cell phone is one. It's a very bad distractant when you're out hunting. It is.
Yeah.
It takes your mindset away from what you should be focusing on.
Nice.
I mean, these new technologies and new tools of modern conveniences are applicable when you're in an environment surrounded by other people that would help, in the sense that if there's danger coming, they could help give you that nod of there's danger coming your way, so you better be looking to identify with. More new technologies in terms of what's more convenient for you is like the global positioning system, the GPS. That's something of importance to identify with in terms of using it and setting it on the ice and making sure that there's been no ice fracture behind you and you're drifting away. And if it remains still, utilizing the compass, then you're still in a safe mode. These are a couple of examples I could share with you right off the
Yeah. So one other question, maybe for you, Craig, or perhaps you, Mike. We sort of skipped over this. How many whales did you see in that census that led to the establishment of the quota with caution?
Well, initially, I think, the raw count was about 600 animals. They might have been corrected twice that. Then eventually, we had, everything's driven by the sea ice conditions and all that. And finally, in 82, we had a very good count. And then finally in 85, we had a full acoustic array. And I think we saw maybe, thinking back, but 2,500 whales visually. Evidence that we were seeing about half the population at that time. So I think the estimates bumped up to maybe 5,000, which was initially what Ituk and others, Harry's fathers, was suggesting about the time of the moratorium. But nonetheless, so that was a big deal. And then, like I said, having evidence to prove to the scientific community that they were increasing, as the elders had said. At Barrow and every community, you talk to an old timer, they say there's a heck of a lot more whales now than there were. So anyway, those are some of the raw numbers. Current estimates about 17,000 plus, high reproduction. So finally, after 100 years after Yankee whaling ended, by some estimates, bowheads have fully recovered. So kind of and still increasing. Yeah, we have. Actually, that's a whole nother discussion, but it looks like we have not seen an inflection yet on this population. They're still going up, so.
Well, so that's a good segue, because yesterday we started the conference hearing from Kirk Johnson about the evolution of the Arctic over millions of years and that hothouse period and this cold house Arctic that we know and that bowheads know. Is changing in a way that we've never seen before. And so that really gets to a question that came in from the audience that says, well, models suggest that even if we move to alternate energy sources, we will likely end up with summer sea ice at levels like we saw in 2012. Do we know enough about the resilience of bowhead whales under those conditions? And so I think that's an interesting question, because you guys told a very compelling story of how the science were missing what the hunters were telling them. Eventually, the science came up to speed and confirmed what the hunters had been telling them. But now we have a question that science hasn't experienced, and I don't think whalers have experienced, essentially ice-free Arctic, at least seasonally.
At least not in recent times.
Yeah.
Yeah?
You know, I think the
Migration.
resilience continues to build on its reoccurrences of weather, climate, ocean patterns as they go through their own shift. The less ice presence, maybe more happy whales. If you think of it in a different, from a hunter's perspective, you know, I think these are very important discussion points to be identified with. Resilience has been a part of our way of life as Inupiaq, adaptive, resilient to the circumstances that we are surrounded with on a daily basis. So in applying that to the resources that we depend on for our sustenance, there's got to be a positive. If there's that perception of there's no real disturbance to the resource. I mean, these are key issues that we need to identify. If there's no real disturbance to the resource, then it can survive pretty much on what it's currently doing.
Mike?
Yeah, I chaired a meeting for the IWC Scientific Committee back in the middle 80s, something like that, about what would be the impact of climate change on whales. And everyone was saying, well, the impacts on bowheads is going to be obvious. As soon as the ice starts melting, their populations are going to plummet. It's been a couple of decades. We know that the area is warming, has been warming for a couple of decades. And the science goes on, the monitoring goes on, as you have heard, no evidence of any decline. And in fact, if anything, they are thriving.
Acceleration.
Trajectory is still going up. So we aren't there yet. And as long as the science and monitoring are going on, the U.S. would be quite comfortable. You know, I mean, the question gets at, well, does the hunting get to continue? And the answer is yes, it does, because everything is positive so far. And but if declines start happening, I think my colleagues would be the first ones to say, we've got a problem, we've got to start looking at this and seeing what's what.
So I'm really struck, Mike, by your use of the first person plural here, we, because, and I think it's astounding. I mean, I can remember that period where it was so tense, right?
And it wasn't we.
And it wasn't we, yeah. But I think, you know, the real heroes of this story, from my outsider perspective, are your dad and your mentor, Tom Albert, who made people keep talking and keep working together even when there was such animosity and there was such distress in the community. And that's a bigness that, you know, that's hard to imagine, to just keep the conversation going. And that's kind of what we're about in this big tent, is the conversation has to keep going. We will have some really tough conversations as the climate changes. We're going to get really stressed. People's families are going to fall through the ice. People's resources are going to be challenged. That doesn't tend to bring out our higher angels, but we're going to need leaders who will keep us coming back to the tent and to the conversation. Yeah?
Yeah.
It's late. There's food and beverages, and the special treat that we have. George Nowak is he's brought his drum, and he's going to drum and sing for us. And please, please do not neglect our colleagues' posters. So enjoy the wine, enjoy the conversation, enjoy the singing and drumming, and enjoy.
Thanks, everybody.
Mike.
Yeah, I'm gonna tickle you again. There you go. Thank you so much, sir.